in charges of Sumshodhini'21 Mechanical, who tremendously worked hard in spite of the difficulties to make this fest technically, professionally set on standards, Miss Sumitra ma'am, S. Anil Kumar sir, and Vinod Kumar sir.
Yes, thank you, sir. Thank you, ma'am. Now I am honored to welcome our idol of knowledge, the most disciplined yet the most student friendly, sir, the head of the department, Professor Dr. K. Rajanarendra Reddy, sir.
Now let us welcome our resource person, Chief Guest Shri K. Harshavardhan sir.
Yeah, hello. Good morning. Good morning, sir.
Morning, sir.
Good morning.
Good
Good morning,
morning.
sir.
Now let us start this fest.
Good
Let
morning.
us in a very beautiful way by inviting the Almighty, that is the Invocation Song by Shruti from final year Mechanical 1 section.
Yes, Miss Shruti.
स्वागतं सुस्वागतं स्वागतं सुपच्छ्वागतं स्वागतं सुस्वागतं स्वागतं शुभस्वागतं स्वागतं 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 स्वागतम् నవరస శోభిత ప్రాంగణమునకు సరస హృదయులకు స్వాగతం పూజులు విఘ్నులు కళాబంధువులు శ్రోతలందరికీ స్వాగతం సుందరం సుమధురం నేటి సంబరం శుభకరం దివ్య స్వాగతం 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 పారిజాత సుమ సౌరభాలతో మరుమల్లెలు విరజాజులతో స్వాగతం 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 ముఖ్య అతిథికి స్వాగతం మధుర భావాల మందారాలతో ఆదరపూర్వక వందనాలతో స్వాగతం 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 ఆత్మీయ అతిథులకు స్వాగతం మనోల్లాసము రసానందము సంధించుట మా భాగ్యం మనోల్లాసము రసానందము నీకందించుట మా భాగ్యం స్వాగతం సుస్వాగతం స్వాగతం శుభ స్వాగతం 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 థ్యాంక్ యూ everyone.
Thank you, Miss Shruti, for this beautiful song and blessing us with this pious feeling. Now I request our student coordinator Satvik Reddy to address the gathering.
A very good morning to all dignitaries and participants present here. This is Satvik Reddy Dudipala, the student coordinator Sumshodhini'21 and President MESA. For the past few months, we have been endeavoring as hard as possible to deliver an erudite experience through industry experts here at Sumshodhini'21. In that homage, we, the core team of Mechanical Engineering Students Association, has decided to conduct a workshop based on electrical vehicles, which is absolutely a ray of sustainability for future. Our department is proud of Mr. Harshavardhan Kanmula, our proud alumnus, founder of Uton Energia. We thought of providing a live interaction session with our proud alumnus, building of electric vehicle. But with the COVID wave, it has given a lot of challenges. We would With these challenges come across with the innovation, we did not compromise because of the wave and going to deliver all aspects we have promised as part of workshop here in virtual. To begin, I would like to extend the warmest of greetings to faculty members without whose continuous support and motivation this would have been a distant dream. In spite of pandemic and conversation of offline to online mode of conduction, we took our stand to conduct our traditional events and all the events what we conduct every year, and we have some new events this time. This time we are conducting after today's workshop, tomorrow and after tomorrow, we are conducting paper presentation, which is many innovation and informative presentations are ready to hit the ground. RoboWar, Robo Striker, Powerlifting Rally, Robo Race, Rocket Tricks, Quizohelic are the various events we are conducting for the Sumshodhini 21. The uniqueness of Shamshodri 21 has also inspired the members of our association to plan future research oriented programs in collaboration with industry experts. At the end, I urge you to more interactive with our proud alumnus and peers in the workshop, which helps to get more out of the subject. All the best to the participants. And I would like to thank our dynamic head of the department, Professor Rajan Narendra Reddy sir. We lovely call sir as Rana sir. And I would like to thank our faculty in charges of MESA, who always be a strong pillar to the students of our association. Thank you so much.
Thank you, Mr. Satvik, for giving us the insights. Now I request Sri S. Anil Kumar sir to give the brief report.
Good morning. May I audible to you?
Yes, sir.
Yes, sir, you are audible.
Thank you. Good morning to all. Respected HOD sir, Professor K. Rajanarendra Reddy garu, and senior faculty, students, and my MESA coordinators. Mr. and Mr. K. Harshavardhan, founder, CEO, today's resource person from CEO Udan Energy Hyderabad, and proud alumnus of ME batch of 2017. I proudly say that our mechanical engineering department has conducted first pre-symposium under the umbrella of Sumshodhini, under the guidance of Dr. K. Ishwarya sir as well as and Dr. K. Sridhar sir. In 2015, we have conducted 4 workshops, which is IC engines, AutoCAD, CNC, and composite materials. And coming to the 2016, we have conducted only on the Ignitis on 2016. And 2017, we have conducted the 3D printing, that is new technologies which are converted from conventional to the non conventional to the non-conventional. And 2018 also we have conducted one workshop which is nothing but the smart mechanical systems, as well as 2014 we have conducted spacecraft design, and 2020 the new technology which is nothing but in online we have conducted aero modeling of drones. And today, in this year, we are conducting 2021 building an electric vehicle. Like this, we have conducted so many events under the umbrella of Sumshodhini 21. Not only these workshops, we have conducted the very more technical events. We have gone through the from 2015 to 2021. You can observe that how the changes will be takes place. That is how the transformation of the technology. And with this, I will with this I will conclude that 2021 under the Samshodini we are conducting building an electric vehicle. Uh, in this workshop, you can enjoy the students' participation. Thank you, Ananda. Over to you, Jafar.
Thank you, Anil sir, for giving us the insights. Now I request Sri G. Vinod Kumar sir to address this gathering.
So very Very good morning to all the faculty members, head of the department, all the senior faculty members, and my colleague S. Anil Kumar sir, Sumitra madam, and all my dear student friends. So, welcome to this particular workshop that is building an electrical vehicle. So, while coming to the workshop, so we are going to see what is an electrical vehicle and how many types of electrical vehicles will be there and how they are different from the conventional internal combustion engines, and why the evaluation of electrical vehicles has been developed. What is the necessity of developing the electrical vehicles? And we are also going to see what are the various components of electrical vehicles, right? So all will be done in during this particular workshop, and uh, I I definitely say that you people are going to definitely enjoy the session, and wish you all the best, and thank you for giving me the opportunity. So over to you.
Thank you, sir. Thank you, Vinod Kumar, sir, for giving us the insights. Now I call on board our chief guest, Sri K. Harshavardhan, our proud alumnus, founder, and CEO of Bhutan Energia, Hyderabad. Over to you, Zafar.
Yeah, let me give a brief intro about our proud alumnus Harshavardhan. He was passed. His batch was from 2013 to 17 from Mechanical Engineering Department, and from 2017 to 19, CTO, Sina Mobility, and IIT Madras incubated startup. And from 2019, very recent times, he is present, the founder and the CEO of Uton Energia. And over to you, Harshan.
Yeah, good morning, everyone. Good morning, Raj Narendra Reddy sir. So it's also Anil Kumar sir and Vinod sir. It's been so long to see you, and thank you for giving me this opportunity. And I would love to give my insights about the workshop. Definitely, for the next 6 to 8 hours, we'll be definitely focusing on how brief this electric vehicles about and the journey that we have been, and what is our how do you start from conventional IC engines to how we are shifting to the electric vehicles and all. And it's so good to be part of this workshop because I have been sitting in the other side of the workshop always. I've been participating in many workshops when I was back at the college. It was very informative back in these days. I hope to make this as much as informative as I can, and I would love the participants who are there here to be as much as interactive as possible. At any point of time, I would love to welcome your questions. So yeah, it's thank you for giving me this opportunity, and Vinod sir, you've been following up, and yeah, so this is it's good to be here. So yeah, we can definitely start the workshop if in case there are any other formalities to be done before.
Yes, thank you, Harsha, bro, for giving us the insights and giving a brief report on your career and guiding us, and you as well as an inspiration to all of us. Thank you. Now I request our beloved HOD sir to give the presidential remark.
Yeah, good morning. Good morning, Harsha. Warm welcome to this wonderful workshop. Yeah, most respected principal sir, and most respected principal Dr. Ashok Reddy garu, and most respected management members, and our beloved Dean Student Affairs Raghutam Reddy, and Dean Associate Student Affairs Narsimha Rao sir, and Chairman IST KITSW Warangal Ramesh Babu sir. Warm welcome to each and everyone. Dear students, this particular workshop is designed to help you to know the content beyond curriculum. Right? This is the workshop which is being organized by our dynamic faculty members, Vinod sir and Anil Kumar sir and Madam Sumitra. During this particular pandemic, they are terrifically attacked with the pandemic in spite of their health issues and challenges among their family members. They have given top priority to provide all the best resources, best facilities, and latest information in the field of mechanical engineering. I personally advise all the students to take care of their next 6 to 8 hours to give top priority to the learning program. On behalf of the department, we personally congratulate all the student organizers. Conducting one event in offline mode is very easy, but in coming to the online mode, they have to take care of many parameters. But without any hindrance, they could able to meet all the requirements. So we personally advise entire MESA organizers under the leadership of Satvik Reddy. Uh, on behalf of the department, we congratulate all the organizers and the faculty coordinators of MESA for conducting this particular program. And on behalf of the institute and also on behalf of the department, we personally thank our beloved alumni, Mr. Harsha, for taking care of his precious time in spite of his hectic ongoing R&D activities and handling his own team members towards a better future. He could able to spare his precious time to support our student community. So this is one of the spirit of all the alumni of mechanical engineering. So they are ever ready to support all the budding engineers. We are really proud of you, Harsha, the way you are progressing in professional arena, and we are really proud of your serving motto towards your alma mater. Keep continue interacting with our budding students. You are the source of light. You are the source of hope. You are the role model for all the people, for all the students who wanted to start their own startups. All the students who want to grow big time in varied fields. In spite of their learning in mechanical engineering, now you are opening a door. Really proud of for sparing your precious time. I know this particular session will impact our entire participants to enhance their thought process. I know this will be one of the most inspiring session in the field of mechanical engineering during their entire tenure, the entire span of education of 4 years. So that's all from my end. We wish a grand opening through your 6 hours long educative program. Right. Thank you so much. On behalf of the department, I thank all the faculty coordinators, all the organizers, and all the participants for their overwhelming response. Thank you.
Thank you. Thank you so much, sir, for acknowledging us, guiding us, and helping us in each and every aspect. You stood along with us constantly. We thank you so much, sir. So next, I would request Vidhi to present vote of thanks.
Thank you, management. Thank you, faculty coordinators, student organizers, and IST, Technical Club, MESA, PMC for helping us to set the conduction of this event in online mode and helping and guiding and constantly mentoring us all the way to make this possible and setting the legacy of Kids College. And I also thank our head of the department, Dr. K. Rajanarendra Reddy Garu, and I also thank our beloved principal, Dr. K. Ashoka Reddy, for giving us this great opportunity. Thank you.
Thank you, sir. The session will follow up within 10 minutes. Thank you, sir, for joining. Thank you, everyone.
Yeah, thank you.
We'll have a snap. I request all the faculty and students to please switch on your video.
Sir, we request every faculty coordinator to please switch on the videos so that we can take a snap, sir.
Anil, video only అనుకుంటా Anil. హర్ష నువ్వు కూడా ఒకసారి ఆన్ చేసుకోవా? రైట్, థ్యాంక్ యూ.
Thank you, sir. Thank you, everyone. The session will follow up.
రైట్, థ్యాంక్ యూ.
Guys, I request all the participants to be, stay in the meeting, and also be going to start in 10 minutes. We have a simple small iron person, and I request Mitra ma'am to please play the video of iron person.
Namaskar and welcome. My name is KP Singh and I come to you from the Institute of Management and Foreign Studies. The Institute of Management and Foreign Studies was established in the year 1997, and in our 25 years of existence, we have helped shape the career of over 50,000 students. Why is it that we talk about studies abroad? What is so great about going abroad and studying? Well, it's a very simple fact that the world is moving at an extremely fast clip. And if you, the student of today, the engineer of today, is not prepared for challenges of tomorrow, you are going to be left far behind in the race. Whether it be to talk about agriculture or agricultural engineering, using robotics in various streams at an increasing pace, or the use of data science to help make life better, or using computing power to help human life become easier, there are rapid changes happening. And if you are unable to keep pace with these changes, unfortunately, you will be left far behind. And that is why we encourage you to look at the possibility of you attempting exams like the TOEFL or the IELTS, both of which will show your provenance, your command over the English language. And believe you me, they are compulsory, whichever be the university, wherever in the country, in the world you go to. At the same time, you need to give exams like the GRE, which basically form the crux of your admission. Just like you want to go to IIT, you have to give the joint entrance exam in much the same manner. If you want to do a master's degree in the United States and in other countries around the world, you also have to give the GRE. And that precisely is what we do at IMFS. Train you for these exams like the TOEFL or the IELTS and the GRE, and help you understand how to build your profile from participating in activities like sports and organizing events. Each one of these is extremely important. And that is why when I speak to you today from the Institute of Management and Foreign Studies, the most successful test prep institute anywhere in India, I feel extremely happy to be able to say, well done to all those kids who've organized Sumshodhini'. My deepest congratulations and oration to everyone in this team. Activities like these will help build your profile. We are located in Warangal, not too far away from KITS Warangal. So please come in and experience the joy of learning with IMFS. Let us reach across the aisle and guide you, holding you by your hand to a wonderful career in your lifetime, to greatness in your lifetime. On behalf of the entire team at IMFS, I wish you, the children of KITS Warangal, a wonderful day ahead. Celebrate and enjoy. Till we meet again.
Thank you, Smitra ma'am.
Thank you, ma'am. And the session is going to start within 2 minutes. I hand over the session to our proud alumni, uh, Ashwardhan.
Yeah, good morning, everyone. Satvik, please confirm my audio.
Yes, and it's clear.
Yeah. Able to see the screen as well?
Yes, and it's clear.
Yeah, all right. Yeah, so good morning, everyone. Welcome to the workshop on building of electric vehicles. So I'll just run through, like, first of all, what we'll be doing for the next 6 hours, basically. So first of all, it's like, first you'll start with why there's the need to shift to electric vehicles. That's the first key point that we'll be discussing, because you could see that whole world is transitioning to this new part of this technology, where it is bringing a lot of change, not only in the like you could say, I would say, the environment part, but it's also the whole in the engineering aspect of it. So because we are more concerned about, like, environment all the time, but this single factor doesn't always contribute to the environment. So that's the reason, it doesn't only iterates to the environment factor. It also goes whatever we are doing with the engineering part, and whatever the energy fuels, I mean fossil fuels, that would be saved for the by using these kind of technology. So first point that we would be discussing would be the technology shift, why there is a need for technology shift, IC engine to electric vehicles. And slowly we'll be moving on to what exactly does an electric vehicle contain. First of all, like how it differs from a typical IC engine. So we'll be discussing the whole factors for electric two-wheelers and four-wheelers and whatever the like commercial trucks or whatever it is. So this is how, like, how did the shift happen? Why is there need for a shift? And when you are slowly transitioning from IC engines to electric vehicles, how do the whole paradigm of the ecosystem change? So how do you work around this technology to make this work, get into the people and make people to use it? So that is how that is what is the technology behind it, and how the existing companies or people are really trying to work around it to build an ecosystem around it. So that is how we'll be seeing the next part. And slowly we'll be going into, I'll be just briefing into for the next 2 hours. We'll be briefing into what are the more individual components of electric vehicles. You could see, like, be it a battery or a motor or the other components. And does it limit to battery or motor, or what are the components that get affected when you're changing the whole IC engine and replacing it with a small electric motor or something? So how does each and every system change when you're shifting from an IC engine to electric vehicle? So that is how we are going to discuss for the next 2 hours. Then after a small break, we'll be definitely going for a structure around it, like, for how do that structures variation, like, you typically in our mechanical engineering terms, you could call a bodies like internal structures or internal frames, bodies. In industrial terminology, you'll be calling more it as body in white, something that doesn't like, only a typical engineers would be knowing, because that is the internal part of it, the internal structure of whatever the cars or vehicles that we are running right now on the road. That is a key part, so that we'll be discussing body in white. So we'll be discussing different types of frames or structures that would be using in electric vehicles. And why is there a need for a discussion for the frames? You could typically use a same structure or a same frame that we are using in an IC engine. So does it really affect if you're sticking to the same frame, or does it really affect if you're changing the frame? So that is one factor we would be discussing. And the other would be, like, the next part we would be focusing would be, like, the drivetrain part of it. For the electric two-wheelers or four-wheelers, the suspension handling, or you could say the automobile part of it, would almost remain the same, especially with the vehicle dynamics if you're considering. But if you're talking about the main thing, it would be the change in, like, drive system. Uh, how an IC engine efficiency varies from an electric vehicle efficiency. What are the changes that you could see, and how many parts? As in typical mechanical engineering terms, we say, like, more the number of parts, lesser the efficiency, because it is creating a lot of vibrations and all. So that is how we'll be going through in each and every step of it. So this is the curriculum for today. Like, first would be the basic introduction about electric vehicles. Then we would be discussing the components of like the whole out and out structure of the electric vehicles. Then we'd be focusing mainly on the internal structures of an electric vehicle, be it of electric two-wheeler or four-wheeler. Then finally, we'll be discussing about electric motors and batteries and drivetrain, to be specific. And we'll have a small video of a complete individual components of an electric motor. So, and how it is designed, and how does manufacturing affect in electric vehicles. So this is the curriculum, or this is the whole schedule for the today for the next 6 hours. In the meantime, first I'll make it. I'll make myself known to all of you. So basically, I'm Harsha, and I've been part. I've graduated from KITSW from 2017 batch. So started in 2013. So it comes down to all the mechanical engineering in KITSW. It's actually the best part of it. So right from the first second year, we've been gone to the core of mechanical engineering, and there has been a lot of support from the faculty as well. So our main, I would say the main thing that helped us to grow in a college, I would say, is like the support that faculty has given for us to from us to develop this electric car. I mean, race formula type race car, which it's a formula student competition. So from there, where we could grow on typically building a race car from scratch. So right from your frame, body structure, suspension, dynamics, then again IC engine part. So tuning the engine and also testing, validation, and all. So this is where our journey started basically, because exposed to the real world of manufacturing and challenges that you incur on a daily basis when you are in an industrial level. So that is where our journey has been started, and that pushed us to really go into a different stream rather than building something. So that has always been a motto even in the company that we do right now. So we that helped us to really grow basically. I would say, rather than, you could see, like, you can always find a component that is available, but what helped us to what made us to build a company is that. Hello.
Harsha, Anil Kumar sir.
Yes, sir.
Sir, full screen better అండి.
Sir?
Full screen పెట్టండి.
Slide share.
Screen.
Oh,
Slide.
yeah.
స్లైడ్ ఒకసారి మూవ్ అవుతుందో లేదో మూవ్ చేయండి. ఫస్ట్ స్లైడ్ లో పెట్టారు.
Okay, sir. Yeah.
Okay.
Okay.
Yeah.
Thanks,
So
thanks.
yeah, thank you, sir. So basically, yeah. So that was the main intention actually. So even in the company that we built so far, we have started back in 2019 January. So I would say, like, this is how the journey started. Like, I was working in a startup. I was part of this technology team there. So I was heading the technology team right after I graduated from college. So I would say, what again, I would suggest people, like, this would be more of a interactive session. Any questions, you can drop it off at any moment. You can just switch on the mic. And so yeah, so running through my journey. So right after the college, I've been into this technology team at a electric vehicle startup. So why, that was a question actually. Basically, how would people directly take you into the technology team? Because there is no prior experience. But what I would say is, whatever the things that we have built during our graduation, what are the knowledge that we have got, so and the support that has been. So that is how we have been, during the beat, during our college times. So that helped us to directly get into the core knowledge of core industrial knowledge, I would say. Yeah, getting in, like, industrial standards are completely different from what we do at colleges and all. But there's obviously a difference. That this college level provides you a basic step, that will drive you to this industrial standards of building the components. So that is how I went to. I've been into the CV startup and worked there for 2 years. I was heading the technology team right after like 6 months. So then, yeah, so the core part of the company was to build a self-balancing technology for two-wheelers. So yeah, building a two-wheeler that can balance by itself. So that was a key thing that we have built there. And later on, when I was working there, I was actually part of this. I mean, I was using this metros to commute to work every day. That's when I found it difficult to reach my first and last mile. Like, I have to go to the metro, then get onto the metros, then get down at metros and go to the work. So this part, metro part was easy. I mean, I would say that between commute was easy. Then I thought, like, how do I get to metro? Or how do I, from metro to the workplace, how do I get this? So that's where it's back in 2018. I thought, like, there has to be a common junction. Like, there has to be there is like disjunction here. So that's where I thought there has to be something that gives me an opportunity to go around it. And also, you could see most of the times what we do is, like, we hardly commute like 5 to 10 kilometers. So that has been the most, even when you're in, like, at home or like colleges, going to college or back to home. It's hardly like 10 to 12 kilometers. So that's where I thought, like, there has to be some groundwork, something that actually provides us with a good purpose of, like, energy consumption and all. So one key thing was to, I thought, like, I'd be putting like starting some ecosystem or a platform where people can just go to use a bike to go to the metro, drop it there, or book another bike from metro to workplace. So that was our initial thought, where we started of building with building building the whole ecosystem. But what exactly helps you to build this ecosystem is, you don't have to use a lot of this IC engine vehicles, because electric vehicles are more efficient. That's where what we thought is, like, we could use this electric vehicles to build this ecosystem, to build this system where users can find a bike nearby, just take a vehicle and commute to the metros. Then how do you make it, like, more accessible to the user? So that's where we have used cloud, actually. So it's like, you're driving a bike on your phone, or, as you would say, like, most of it would be like, it gives you a typical feel of an IC engine itself. But the whole advantage of building the electric vehicles is you can play around it. There's a lot of factors that contribute to this electric vehicles. I mean, like, which constraint us during. I mean, like, when we are building an IC engine, a lot of constraints that you come across. But that's not the case with IC engines. So that's how we started in 2019 to build an electric vehicle that actually is completely efficient, as much as efficient as possible, and contributing to other factors, good battery range, battery swapping. You could charge the batteries at home. You can remove the batteries, and something like, like theft detection systems. Yeah, that's what, like, when I told that, yeah, so you can play around the system when the key part is like electric mobility. But there are a lot of constraints when you're talking about an IC engines. Yeah, so that's how we started. And currently, so Uton Energy, I would say, utility and energy. When I talked about electric vehicles, it's always energy consumption that actually helps you. So it is one of the efficient systems that we can build. It is way comparative to IC engines. Like, if you could discuss about, like, the efficiency terms, hardly an IC engine gives you a 36% efficiency, while electric vehicles can run up to 92% efficiency. And sometimes it runs even more, depending on the type of vehicles that you've been using. So we wanted to utilize the energy efficiency of electric vehicles. So that's how I've come up with the name Uton Energia. So we have started back in 2019, main aim to discuss about the first and last mile commutes. So as I told, like, we were using that efficiency of the electric vehicles to pave the path for the urban commutes. So when I told urban commutes, it's more of a, like, last mile, like, first 5 to 10 kilometers or 10 to 12 kilometers. You could see, like, we are building a complete range of electric vehicles. We're not limiting ourselves to electric two-wheelers or electric. First, initially, we started with an electric bike, electric moped. Then again, we're going with an electric scooters now. So yeah, so we are not constraining ourselves to a particular segment of vehicles, I would say. We're slowly transitioning ourselves to initial low-speed electric vehicles to high-speed electric vehicles. Then from that to, autonomous two-wheelers. Then like, it's a new concept that we are bringing out, rather than just building an electric vehicle. So we are coming up with a new technology that could leverage that electric vehicle part. So yeah, as I told, like, we started back in 2019 with Siddharth. Is one of, like, he's my brother itself. He heads the technology part here. He takes care of the complete electrical vehicle, or you could say the battery part, the you could say the electronics behind it. You could say he's the brain behind this. I take care of I head the mechanical designs and these things. So Shiva Prasad, he is also one of our alumni. He started right away after his college. So he's currently in the product design as well. And we do have an R&D team of like another 5 people. We are actually involved in electronics and IoT part, Internet of Things. Then again, you have like someone dealing with the manufacturing parts. So yeah, so this is our core theme that we started with, like, what exactly has to be the theme that we build electric vehicles with. So our intention when we started was to provide fun for the fun factor. You don't use this existing IC engine designs, because we'll be discussing that in the coming the next couple of hours. But as I told, like, our intention was not to just build an electric vehicle, to provide a lot of other factors to that. So that's where we're using a lot of technology like digital twin, autonomous detection of what's fault with the vehicles. Then again, you have uh, IoT, IoT and digital twin combined to give you like like you have machine learning and AI for detection of like failure in the components. So that's the thing. So we haven't really just built a vehicle, but we have built the vehicle with a technology purpose. So it's a complete technology based product. This you see, also the point is, you have to, when you are slowly transitioning from a industrial level to building your own company, the point here comes is like how well you are building a vehicle to your user. So that is how the key thing would be. So that's how the main consideration was. And we use the technology to make it more accessible to the user. uh, and the other factors was design and fun factor. Provide fun factors to the electric vehicles. When I told you would be riding your bike on the phone, it's actually more of a fun. You would be knowing everything that's happening with an electric vehicle completely. So that is how we have built the vehicle too. So discussing more about this factor, like, uh, yeah. So every company or every someone, when you're starting something, there's some motto behind something. So this was our motto. I mean, for the designs, I would say, for the products that we release, this is the motto that we follow every time when we design a component. So yeah, you could see the first image, like the first electric scooter. I mean, like, it is actually a second product. So sorry. Yeah. So this is our second product actually. So we haven't released that in the market yet. So this, which would be launching in the March of it. You could see mostly in the near Hyderabad metros and all. We've already worked around with L&T to go ahead with putting these vehicles. So what happens is, as a user, it's a free floating dockless mobility. Like, for example, you're coming with you can park it anywhere actually. So you have booked a bike at metro, you took a bike, then you wanted to reach at some place, you can park the bike at that place only. But that's not the basic part. There's actually a lot of technology behind it. It's not like, it's not just the GPS or GPS tracking that we do. It's actually, there's a lot of other technology involved. But to put into the electric vehicles terms, so this is what we have built around the vehicle. So one charge of it can give you actually 100 kilometers range, and it could run you for like 4.2 hours. And the one key thing that we have developed is, it's a battery swappable battery technology. You can just remove the battery out of the vehicle. You could see this part here. So sorry, this part here. So this is the first. I mean, like, you can remove the battery and you can just swap it in, like, hardly like less than what you do in fueling. So that is how we have built the vehicle around. So currently the vehicle is operates at 40 kilometers per hour. So we are slowly building out another model with the same design coming at 65. So that would be another next step. Then coming to the, like, we've used an aerospace aluminum grade. So you could be everyone, you have part of this. You have gone to the second year mechanical engineering. You would be knowing more of a materials and structures. So what we have done is, we have built an only purely aluminum based chassis. It's an frame built out of only aluminum and aluminum sheet metal as well. So this 7075 series, you basically use it in aerospace applications. Like for example, Boeing 737. I'm sure a lot of you must have heard about uh, this 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 typical aerospace application. So Boeing or any other company in the aerospace uses aluminum to uh, build their plane structures and all. So the reason for using such a strong grade of aluminum is that it is subjected to a lot of vandalism outside the road on the roads. Like a lot of people will be using. It's not a single ownership model. It's actually a rental model. So a lot of people would be using. So that's where we have built using a 7075 aluminum grade. Now, when I tell about 4 to 5 years of lifetime, it is for a rental model. When a lot of different kinds of people will be using. It is not subjected to a single person. It is subject to a lot of people. So that is the reason the lifetime is very like 4 to 5 years. Now this is the existing model on the road. So see, you could see with a bare body, you could think it as an bicycle kind of stuff. So it's a moped that we have built. So with the same speed application, 40 kilometers per hour. And so here you could, if you could see my mouse pointing here. So this part is I mean, under the seat, if you could see, that's where the battery lies in. So you can just swap out the battery. I'll be discussing more about battery swapping and its technology and how it helps in you. I mean, basically adapting to this electric vehicles. I would say, easily. I mean, you could charge it. I mean, you can just remove the battery and you can charge it just like your phone. So I'll be discussing more on the battery part later. But so I would say this is what we have built with we have built every component here itself. So that is one key part here. So I would say 95% of it is being manufactured in India, which is like 60% here in Hyderabad here itself. A few other 35% is being outsourced to manufacturers across the country. So that is how we have started. And 5% is being lithium ion cells, the battery part. So cells is something the typical battery remotes in the TV remotes, you could see like that, those are called AA cells. uh, those are not much powerful, I would say, to run a vehicle. I mean, to run a TV, absolutely, but not to run a vehicle. So that you usually I mean, we all must have done it, try to when the battery in the TV remote is over. So we all try to remove and the outer shell of it and see what's inside. I mean, I hope I mean everyone has done in the childhood. So that part, so that's where the key thing is. Outside structure, what you see is just a insulation part of it. So the inside thing is what you see is cathode and anode and electrolyte. So that part here, I mean, it's a very good opportunity for someone who is actually planning to build their own company here. So basically, the point is this lithium-ion cells are not available in India. One key factor is it's not that any of these companies has manufacturing capability, but the key point is we don't have lithium reserves in India. But what ISRO has come up with is a new technology for a sodium type of batteries or aluminum batteries or different kind of battery technologies. But whatever the companies or whatever the electric vehicles that you're seeing currently in India, I mean, every company in India has to get this lithium ion cells from anywhere. Like it could be South Korea, Japan, China. Obviously dependency on China is quite high, especially for the cells. It's not that India is not capable of building the cells, but what I could say is more of a the inside lithium based extended, which is not available here in India. So that is the first part. Then going into here we have used a different kind of frame structure and different kind of frame material. Chromoly steel, one of the strongest steels available, one of the strongest material available in the steel segment, I would say. you know uh, what factors do you consider when you design a frame, so which again we'll be discussing in the next coming hours. But what I would say is one of the highest strengths in terms of like bending strength or tensile strength or whatever the other factors, which is tensile is not anyways much useful in building an electric vehicle or any kind of vehicle. It would be more of a bending stress or something. So that resistance to that bending stress is something that which is quite higher in the chromoly steels 4130 grade. I'm sure a lot of you, I mean, most of you are aware of this grades, AISI, which would be SAE standards, AISI, ASME standards. So that is how this, I mean, like particular carbon is being rolled or like is rolled and formed into sheets. I mean, like tubes and all. I hope you are aware of this rolling process and forming process in steels. So I mean, as I told, like everything what you study in engineering is a base for what you build outside when you come out of the college. Like the material, the first part of it, the core part of the mechanical engineering when you start is like the materials. So that helps you to go on with whatever the next parts of it. So the key to understand the next mathematical equations that you build in dynamics of machinery, or when you're building mechanisms for machinery. So it all starts with materials. You need to understand what properties of the material that could help you to build a certain application, certain structure for an application. So that is the key. We do a lot of times, like in the industry standards, in the industries, we do really discuss a lot about the materials. That really makes the difference. For example, I would say like you could see that 4130 chromoly steel, and when I've put here it's 7075 aluminium, right? The density varies like it's like three times what the steel is. It comes down to 2700 kg per meter cube, but it's where it is 7800 for steel. And you could see with the same specs and the same almost the same battery, we could offer a range of 100 kilometers for this bike. But when it comes down to the steel, the weight goes on increasing, and but the range comes down. You must be aware, like when you are increasing the weight on a structure, the efficiency obviously decreases. I mean, not always the case, but especially when you're running a engine based on a fuel or something. So yeah, so that is how the materials really affect in this thing, in any form of building any structures, not only in electric vehicles, I would say. It also affects in every kind of IC engines or any kind of structure that you are building. So material really matters. So that's how the range difference is when you're comparative to aluminum and steel, and that different it usually brings out a lot of difference in the other factors as well. Yeah, coming to the battery part, I'm just discussing about my, like, what are the tech that we have used. Later I'll be going into what electric vehicles are. So it's hardly the one more slide left. So yeah, so coming to the battery part, as I told, these batteries are a combination of cells. I'm sure a lot of you must have been aware of this cars. I mean, like whatever the batteries that we use in cars and bikes. I mean, bikes today, what you see is mostly, I mean, there's a transition happening in the bikes also, that the small batteries that you are using is now a lithium ion battery, a small batteries that powers the engine. So I hope all of you are aware of this, the basic mechanism, how the engine starts with the starter motor, and the alternator continuously charging the battery part. So that battery nowadays, I mean, the shift is very small. I mean, like people are, I mean, like the companies are trying to decrease the weight of conventional 12 volts or 9 volts battery, which is like which uses typical electrolyte of lead sulfate, PbSO4, and cathode and the electrolyte and the anode part. So I'm sure most of you are aware that car batteries are too heavy. Like those are made of lead acid. So as it will, lead sulfate is the material used. So this lead acid battery is what comes with. It's an electrolyte in the liquid. I would say not completely a liquid form, but something of a semi molten state or something like. So what happens is this is a cumulative structure. I mean, cumulative material that is being there. when there is a discharge of current, when you're applying it to a load, so there's a discharge of current that goes every time when you're switching on the car engine. So it starts the battery, right? So when it is discharging, so when the key B is being put and the circuit is switched on, what happens is the current flow through the battery is uniform, because of the state of the electrolyte being used. Lead sulfate being a different kind of material. I mean, like, it's a combined material. I would say, like, it's a more of a semi molten state or a liquid state kind of stuff. So that's where what happens is it stays in a combined form. So even in lithium-ion batteries, it has to stay in a combined form to provide that electrical energy. What I'm trying to tell here is it is in a different form where the current flow is uniform. But what happens is, now I'll give you a small scenario here. Basically, imagine, like how this lithium-ion batteries are being built. I'll just give you a small scenario. So basically, you all do have cells on the TV remotes, right? So those are like typical AA cells or something. So imagine the same cells. Imagine the same cells that is being put together. Like, those cells come up with like 5 volts or 3.3 volts, whatever the voltage may be. I'm considering generic to be a 5 volt cell. So imagine putting a 5 volt cell, single cell. Now what you do is take such type of cells into like, now for example, 5 volt system can't run a vehicle, as I told before, because those things are not, the power consumption is quite high, right? So imagine a system where you are taking a single cell and stacking it in the form of series and parallel. Like, what you do is, series and parallel is something like, to build the voltage and current. I'm sure you have come across these things in plus two, like building an circuit. You do have the voltage and current, right? So what you do is you use these cells to build a battery pack. Now you are using this individual cells to build a battery pack. You could see this battery pack in the picture there. So what's inside it, I'll be showing when we are discussing our drivetrain part or the motors part or the battery part. I'll be discussing more and I'll be showing you a lot of things how this difference comes in. But I'm just giving a small imaginative process. Sorry. Yeah. So you're stacking this you're stacking the cells in the form of a series and parallel thing. Now that's how you form a lithium-ion battery. Now the first challenge here is, when you are stacking individual cells, when you're drawing power out of this battery as a cumulative thing, what happens is the power is drawn from an individual cells. So the problem here is, when I told this 5 volts, like those TV remote cells can't run our vehicles. The reason is the consumption. When you are twisting your accelerator, when you are pushing your accelerator, there's a sudden amount of power drawn. All of you must have driven your bike, right? So that initial torque, you switch on the bike, you just twist the throttle. So there's a sudden increase in the throttle. So the same way engine consumes a lot of fuel, the same way the battery draws a lot of power from the motor draws a lot of power from the battery to push you forward. So when I'm telling that these individual cells are stacked together, there's a real challenge of, there might be a case where a lot of power is drawn from a single cell. When I'm telling about how challenging electric vehicles are comparative to, like, everything has its own challenges, but what I'm trying to tell is the shift to electric vehicles. The challenge here is you have to monitor individual cells. That is where the real challenge is. Like, you have to see how much power is being drawn from an individual cells. For example, I'll give you a small thing. This bike, when it gives a range of 65 kilometers, do you have I'll just give you a rough idea. This battery contains 70 cells, 70 individual cells that are being stacked together. So there's a real engineering that goes into that. Now the real challenge is, how do you monitor the 70 cells? That's the first question. And how do you monitor? Now monitoring again comes down to whom do you want to monitor. If I just build a battery and monitor it, and keep a monitoring system and give it to user, what will he do? Like for example, I'm to a normal user, I'm giving him, telling that you can just monitor the power or cells or current in individual cells. He has nothing to do with that. So that's where the real challenge is. Now you have to build a system that monitors, predicts what is happening with an individual cell, and tells the user what it is required. Not what, he doesn't need how much current is there in the individual cell. He doesn't need how much voltage is being dropped in the individual cell, right? So that is where the question is. Uh, how are we building it really? How are we trying to give it to the user? So that's where we have come up with it. Uh, technology where it actually gives the user health of the battery, just the health of the battery. As a user, I want to know how my battery is. We never got a chance to know. So far we have been running IC engines from like past 100 years, or like 60, 70 odd years. We haven't really got a chance to know about engine's life. I guess at least in the two wheelers it's still the same. Four wheelers we have come up with a different technology now. ECUs, electronic communication, ECUs and all, electronic control units and all. So ECU is really, every system has an ECU, but ECU, how do you want to communicate with the user is something that is very much required. So I'm sure a lot of you must have anyone here has a Volkswagen Polo or Volkswagen Vento. Which is the first car to adapt in India here, at least. So to give you what the feedback of the engine. So the same way, what feedback we give it to the user is, it's just that uh, health of the battery, what is the amount of charge left, any errors, what is happening, any in case what is happening. Like as I told, when you're monitoring individual cells, there are a lot of challenges that come up. So that is how we are building. So this is a removable battery. So all they can do is just turn the lock off and remove the battery under the seat, and you can charge it as a phone. That as simple as it is. And the charging time comes down to 80 minutes. And now we are working on an efficient charging systems that can charge the vehicle in just under 35 minutes. So that would be with the launch of this new product, but still offering the battery swapping technology. That drives more and more people, encourages more and more people to buy or shift to this electric vehicles. The last part of the introduction, I would say, introduction to this, what we have built. So I would say we have built an BLDC, or you could say now the current system, what I've mentioned is BLDC motor. So there are different kinds of motors available actually, I would say. The same way IC engines are driven by diesel and fuel systems. Again, fuel is a different factor, but you have V8 engines, W12 engines, different kind of engine shapes, right? So that is how the same thing goes with an electric motor as well. So there is a BLDC, brushless DC motor. You don't have to use brushes basically. I'll be going more deep into why you need brushes and all, but I'm just giving you a basic and overview of it. Now currently for this system, we have come up with a different kind of motor called PMSM motor. It's a permanent magnet synchronous motor, so, which is more efficient than a BLDC motor, I would say. So again, when I told even every system that we have built gives a feedback to the user. So it's a diagnostic system. How do you the way you have apps in your phone? I don't think most of the people use this, but there's a booster clinic app, or that booster clean app that cleans your whole mobile or diagnoses or something like that. I don't know much of it, or much of it doesn't really work properly. But what we have built here is the connecting the hardware to the software part. That is a key thing. Just not leave it to the hardware. Build it smart, I would say. What we have done is we have integrated the whole system to the cloud, and we take data of the ridings. Every time people ride, we take the data of few factors, I would say. Like for example, how are a lot of like bearings that are all in the electric motor. So how is the graph versus load versus bearing? I mean, like load versus the rotation of it, or load versus the speed. I mean, like speed. A lot of like innumerate, like I would say, data that we take on a daily basis, and we try to optimize the hardware. I mean, like the software part, and this helps us to improve the hardware also. I would say, like first time when we built, we had used like typical steel based rotors and all. Now what we have done is slowly shifted to the composite part. As I told, like every time, there's always a scope for efficiency. I mean, like improve the efficiency. So what we have done is put the composites part. Like for example, there's a certain components in the motor. Yeah, I'm sure a lot of must have known about the composites. Like what composites that we have used this glass fiber and few parts, few small components with carbon fiber. These are the most really one of the most efficient parts or materials that are available. So, and the density is quite lesser than aluminum itself. Like if you are considering the uh, density of a glass fiber or a carbon fiber would be something close to 1500 kg per meter cube. So, like half, like close to half of what an aluminum has. So you could see, the more you're running around the materials, the more efficient system you can build. Of course, it comes at a cost, obviously, but also it comes at a complete lifetime. You're investing in an initial thing, but it doesn't prove. I mean, it doesn't affect your complete lifetime. So we have built one of the most efficient motors with an efficiency of 87% so far. Um, so that is what we have built with the company so far, and it's been like close to 2 years. Yeah, I think it's more than 2 years now. So we have launched the product last year. The first model, this second model I've shown you, and we are doing good number of sales actually. So we launched in February 2021. It's not been a year yet since the product launch, and we are doing good. Like we have crossed close to like 1 CR sales and all. So it's going on pretty good right now. But there's always a scope for improvement. So as I told, like we are also setting up a new production unit in Nacharam, Hyderabad. So replacing the existing one and improving the production capacity to 500 units per month. So and this would be just for the next 3 months, and after that we'll be actually going for a 2000 units capacity. So I would say, like our key markets have been always. I mean, so when we told, like how the let's I mean, we also I would say, like mostly our sales have been like what the product people love more about our product, I would say, is like the technology factor. So people don't uh, so it's nowadays it's more of a like what the best technology that a product can offer, or what is that technology that can interact more with the user, I would say. So that's where attracted the most of our users, and it's been a good ride so far. I hope to continue and build a stream of electric vehicles and really make an impact to the environment, I would say. And second thing is, uh, this would be a good time to shift to electric vehicles, especially with, I don't say rise in fuel prices. There's always a scope of I mean, like you can't really rely on fuel prices, obviously. But what factors that contribute, I would say, is like environmental impact, and second thing is you're using it on a different application. Like you could bring a lot of efficiency with a low amount of energy that you're using. But I would say, like like for example, if you're aware of like the fuel density and density of fuel and density of batteries, so you could say, like with one currently with the price of 1 liter of petrol, I would say you can go around 1000 and 2000 kilometers with the batteries and the vehicles that we've built. So that's how, I mean, I'm not really focused on the price here, but you could see that amount of fuel that you get for $100 and the amount of energy that electric vehicles consume, it's very less. It's minute. I don't say it's minute. Comparatively, it's minute because the efficiency loss is very much less here. And when I told that we have built an 87% an efficient system, it's because we have used chain-driven system. I'm sure most of you are sure of how the connectivity between engine and the wheel. You could see in the bikes as well. So this connectivity we have used a chain drive system, and as I've told, like with this model we have come up with a belt drive system, which is far more efficient. I hope to bring on to I hope to bring on to touch 90s, and like we are, I would say we are more I would say tense than Sachin being in 90s, but we really wanted to touch that number because it could improve the range, battery range by more than like 15-20 kilometers, and that could be a crucial part. You're building you see, you can build a battery of you can build a vehicle of 1,000 kilometers range that anyone could do. That doesn't really matter when you're building something. It's always been how efficient you're building. So that is always been the key. And yes, so this is what we are doing, and I'm open to questions for the next 10 minutes, I would say.
Guys, you can raise your hands for any question. Whatever the doubts you have, you can raise your hand.
I'm not saying like it has to be about the company or something. You could ask me about any technology part or the electric vehicles part only. You could ask about any kind of thing, like about like be it company formation or how do you build a company. Anything, it could be anything, because the next after probably at 11:30 we'll be starting our new thing actually, like how the shift to electric vehicles and all. So that would be more of a technical stuff.
Yeah, thank you, Harsha, for a wonderful presentation.
Yeah, thank you, sir.
Yeah, if in the meantime other people asking question, can you please educate how you got the idea for floating this company so that other people can think?
Yes, sir. So, and I would say I would really have to mention one point I really forgot about how if I would say like the technology entrepreneurship program in the college, I really forgot to mention that, because I you are also part of it when we were in the college during at that time. So you were initiating us to do, and you and Srikant sir when we were there. So I would say like that helped us to, like, first of all I would say uh, anything that you're building, right? Like I'm not saying that building a company alone. So it's all about like whenever you're doing a final year project or being a different assignments that have been assigned to you, I would say there's a different approach that you have to stick to. So that is what I suggest to everyone here, right? Everyone present here. So it's like there's some different aspects of, it need not be a conventional approach. It need not be an approach that is already present. You can build your approach on a different way. What I suggest is to start thinking. I'm not trying to use the words out of the box and all, but what I suggest is build your own approach to what you wanted to do on an in a long time goal. So when you're starting to think like what you wanted to do. So even it might not be starting the company. It might be when you're joining a company. So it always depends on how individually you start to perform, and this depends on the way you think. So when I was part of this technology entrepreneurship program in the college, and design thinking was the first workshop I've gone there. It was really helpful, I would say, like where I was gone through like different. It gave me a whole different perspective on how you see a product, how you see building something. So that's where we have started. And yes, sir. So basically, coming back to like when I was working in during my working days, as I told, like I was commuting using this metros. and that was my really painful. I had to use like autos, or like, which were some most of the times not available. So because that's where I thought there has to be a communication, or there has to be a conjunction between public transport. Like for example, what we are doing right now is like you could see in the next coming 3 months. So that is the idea where we started actually. So it's a connectivity that we are establishing between people commuting in public transports, metros, and people traveling like for the less than 5 to 10 kilometers. So it's a complete platform that we have built, swappable battery station, electric vehicles. So these things would be present at the metros, and you could just take a bike out of it and go it until the last mile. So that is our thing. So when I was working, so this was a challenge. There was no such system. Of course, there've been some systems that have some solutions, or some companies that have come up with the solutions right now. But what makes us efficient, or what made L&T to have a deal with us, is that the complete ecosystem that we have built. So when I told that, thinking in thinking in our own perspectives, what we thought is, the key point here was to convey L&T, and to make them accept our deal, was the whole ecosystem that we have built. It's not only the electric vehicles, or you could see the existing systems have been a real kind of pain, and there is no proper solution there. So we have come up with a complete dockless mobility. So people can just pick up a bike and park it anywhere. And what we are trying to do is, when I showed in my presentation, with the technology that we have built, is always communicating with the user. And also I would say, like, it's always communicating with as a company. So what we are trying to do is not involving user in the problem solving. Like for example, every time you have a problem with your vehicle, you just have to take it to the service station. What we are trying to do, apart from the physical problems or physical damages, what we are trying to do is connect it to the system where we can solve it remotely. Like what I'm trying to tell is, like, I'm sitting here in my system, and somewhere back in, like, any place, if there is a problem with the system of an user, the bike of an user, which is not a physical damage. As long as it's not a physical damage, we can solve it from here. So that is the approach that we thought. Like, building. Like your vehicle. Like the whole vehicle is now on your phone, I would say. So that's how our approach has been. So we don't want the users to come to service station as long as it's something a physical damage. So that is how the approach has started. And so far we have built a good number of user base, I would say, and we hope to increase in the coming next 9 to 10 months. We hope to have a real good breakthrough in the market this time. And also, one thing is that we are also going into the European market this year. So the second model that we have shown, we've already in a deal with few companies in the Europe to export it to the Europe. So we'll be one of the very few companies, electric vehicle companies, dealing with an exports. Like, there are building in, I would say, building in India to the world, I would say. So that is what our motto has been always.
Make in India, make forward.
Yeah, definitely. Yeah.
Really fantastic. The way you are presenting the formation, really amazing. It is most inspiring. Harsha.
Thank you so much, sir.
Harsha, can you add one point? There is a myth stating that whatever we learn in institute is obsolete, right? Outdated parameter. But the actual point is the principles, the concepts we learn in the classroom will pay a strong foundation for a example. You could understand automobile in classroom, understand basic electrical engineering in classroom, and you could understand entrepreneurship development in classroom. Right? You can understand problem solving abilities in classroom. I hope those will definitely will play a vital role in major life-changing transformation activities. Will you add some points on this?
Definitely, sir. I'll love to discuss at length about it. So basically, yeah. So when I was discussing about how we built this vehicles and our vehicles, so basically as you could see, I was focusing much on materials and the properties behind it. So I would say like these don't come when you go outside. These are the basics that you require when you're going on to the industrial level. So many people, I mean, as I told in my first point itself, so this actually acts as a step. When you don't have the step, there is no way you could reach to that industrial level. So I mean, it might sound because I was sitting on the other part of it. I was sitting in the classrooms listening to what professors have been telling. So I would really say these factors really, for instance, right from the way you start building a vehicle or something related to products or something related to impacting into the structure or something, you really required right from the basics, right from I'm not saying I'm not even taking out the first years. No, the basic. Hello. Yeah. So
please.
yeah, so I'm not even excluding out the first years. The point is, the basic engineering physics and engineering mechanics that the brush up that you get here, then later on to that forms a strong basis. Then you go to the materials and the material properties, slowly transitioning into how you can slowly build you can come into a component level. We might not understand that we are building a component here, but you're surely building a component here, or you're surely forming a basics to build a component here. The production technology again, you if you don't really understand how your product is being made, like for example, even if you're in a design team or if you are designing something, until or unless you know how the product is being made, there is no use of the design, I would say. There is something called DFM, design for manufacturing. So what all R&D companies have is like, three phases: design, manufacturing, but the mid part here is the DFM, design for manufacturing. So this is the key of your production technology. So when you don't know how your product is being manufactured, there's the first part here has absolutely no use. So that's how you slowly move from material structures to uh, production technology. Then you go into how each and every structure has its own properties. So then again, slowly moving into I mean the loads that these structures encounter. This is a complete process, and I would say I would be really, I mean, like the curriculum we had, it was a complete smooth process, I would say. Like, the way I could do the problem solving right now was because of this curriculum only, because I was slowly being put into what exactly happens, like, what is a material, then what are the properties of it, then what is the how do you what are the structural properties of it. Now, where exactly do you use this material, and what are the different applications for it. So, and all this thing, it has been smoothly being put. So that is how I could really use, like, the basics that I've got from the college level, and I could build upon it to really design what are the components or what are the vehicles that we have been designing. So it's a complete this thing. What I suggest is, even with the engineering drawing, I mean, I would say, like, I was like bit of initially I found it hard to understand, but without that, there is, there is no communication between designers and the manufacturers. So all the manufacturers requires is just the drawing, not the design file or something that you design in this 3D structures, 3D parts. All they require is this the drawing part of it. So that's where you're lost when you don't know how exactly the drawing principles are. So what I suggest you is build up on your basics. This curriculum really helps you. I'm saying I'm not restricting myself to this electric vehicles or automobile segment. I'm saying everything that you build, if you're not forming the basics of this, that becomes a real problem actually. Every part of it might be useful in either in, like, thermodynamics part, heat transfer part would be a difference. In the aerospace segment, when I first worked a couple of months in science, where I was part of this engine analysis team. So I would say, like, there you definitely need a subject knowledge or the basics of every kind of subjects that you learn at the college level. So I would strongly recommend everyone to go ahead. I mean, like, really focus on that. That helps you to build up strong basics, and with basics comes the problem solving capacity. So my approach, when I was part of this entrepreneurship program at the college, so I found my own approach to do this. I mean, that's how many people do. So my approach has always been to stick to the basics, even it is a very small nut and bolt that you're designing. So I do have formed an approach of building a component or building a structure of an, like, be it an organization, or like if I have to hire someone, I do usually do the same process, or to set up a manufacturing unit, I use the same process. So that problem solving has been, that has to be there. You have, I mean, like, that helps you to have your own identity, like, because an identity helps you to recognize. For example, in our company form, like, when people have to look at our identity and see it as, like, okay, this vehicle has come from this company because the design is such unique, or the technology is such unique. So that's how build your standards. And I'm sure everyone are aware of Tesla, how Elon Musk has been building a standards for the electric vehicles. So I mean it's not like, you have a lot of other companies as well, but there's a standard that you have to create. There's own approach or own problem solving capacity. So that always, helps you to get to the next level. So that is what my suggestion would be, definitely.
Yeah, fantastic, Harsha. The way you are portraying things, amazing. We could able to recollect Harsha in class and Harsha as a CEO. Amazing transformation. Really hats off to you. Really proud of you, Harsha. The way we are really enjoying your session. And,
Thank you so much.
right. So
Thank you so much. Yeah.
thank you so much. Yeah, please continue. Thank you. Yes, Satvik, do you want to give 1 or 2 minutes break?
Yeah, I'll just take a small 2 minutes break and I'll come back.
Thank you.
Guys, hope you are enjoying the session. I would say it's a great opportunity to you to get this type of lecture from our proud alumnus. Guys, take a small 2 minutes break and be ready with your questions and whatever the things regarding this automobile sector, what are the doubts you have, please raise your hands and ask anything, whatever. Harsha brother is ready to answer your questions in a very good way, which is useful to your future, and it may clear you all the doubts regarding the present trend of mechanical role, what going to be in automobile sector. Thank you, guys. Please take a 2 minutes break.
Uh, so guys, let's move on to the next part of it actually. So as I told you, the first part would be basic introduction about the company. And now the reason why I've taken much time comparative to what we have discussed is I actually wanted to make sure that things go in hand. Like it's not only always about ourselves. So what I thought is it would be more to interact with you in a I would be discussing more about the component level when I'm discussing about the company as well. So yeah, now comes the main part actually. This actually should form a base actually. What exactly is an electric vehicle? What are the components that you have, and what are the other? We will be just running through now. So yeah. Uh, Yeah, so I'll first talk about like what exactly is the current state of an automobile segment be it an Indian auto industry or be it in the global auto industry. So we all know that existing convention. I'm sorry. First of all, I hope no one has any questions from the previous small session that we had. So I'll be jumping onto it directly. Satvik, if you can ask anyone with any questions, you can just directly jump onto this.
Yes, Anna.
So should we go ahead?
Yes, Anna, you can.
Yeah, sure. So yeah, uh, so as I was telling you, the existing global industry or the global automotive industry, I would say before 5 years, so before 3-4 years, what exactly it has been. Now, what is this talk about electric vehicles? Everyone's been talking about electric vehicles. You could see like a lot of companies that are coming at your doorstep, like be it in the part of an experience centers or showrooms. You could see a lot of things that are now, what exactly is this buzz around electric vehicles? Why is the need for electric vehicles? Why do we need to shift from an existing technology? We are already comfortable. You have fuel stations established like for every 5 kilometers, 3 kilometers, and let's keep the fuel prices aside for a minute, because the fuel prices are only a great deal in India, not across the globe. So, but just let's keep that aside for a moment. Now, why is the need for this technology? I mean, government is not pushing you because the fuel prices are bringing bottom, but it's pushing you because there is a need for adaptation. So let's see why there is a need. We are already comfortable. IC engines are really good. You could just go to a nearby fuel station, uh, and you're done with fueling in like less than 5 to hardly, like if you're talking about a four-wheeler, it's hardly 5 to 10 minutes. For a two-wheeler, it's less than that. Now, and and you're okay because you just don't have to do anything. And service has been like good part. Like you have to get it serviced for every 3-4 months or 6 months, and the lifetime also has been good because we see people running the vehicles for 1 lakh kilometers or like more than 1.5. And I personally have car that already ran like 1.35 lakhs. So like why are we again need there is a need. I mean, obviously there is always a need for adaptation to new technology. There's an always need to go into new technologies, but this whatever we are suggesting electric vehicles, it's a complete shift. We're not talking about a small engine engine level. You're replacing the whole body of it, like engine, then again you have that lead acid battery, then you have fuel tanks, then you have radiators, then you have like I would say like in two-wheelers it's been like exhaust, silencers, drive chain, gear-based mechanisms, a lot of components. We had to change. Do we really have to change to that? Keeping about the fuel prices. So I would say like automotive sector. What key thing in the current? I'm not talking about an automotive sector. I would say complete transport. Let's focus on transport. So what happens is you have environmental concerns are always there, but does electric vehicles really help you to stop these environmental concerns? Probably up to like 20% or 30%. Like you're considering like Delhi has been a good example. Even though there's an adaptation of electric vehicles coming in, it's a good progress that you could see in Delhi. Environmental concerns are really good, and the impact also has been really good. But that we can't eradicate that 100% because there's always a scope of like fuels coming out of this industries and all. So let's keep that environmental sector out. Let's keep out that costing out. Now, what do we left? What are we left with? So. So yeah, so these things contribute to economy part of it, like Indian economy part of it. Now, but what contributes to, why do we need to have a shift in this electric? So you could see this image right over your screen. Like right left side on the screen is your engine, and the right side of your screen is the electric motor. So this is for a typical two-wheeler, and you could see like these things. I mean, I've taken a typical two-wheeler engine for a high-end bikes, high-end motorcycle bikes, and the same capacity. The reason you could see there's a difference in the size, but the capacity is typically same. Now, why there is a need for shift in electric vehicles. Let's discuss about the shift part, then go into the electric vehicles part. So basically, I'll first go on to my next slide, then come back to this. So yeah, here is a small thing. I'm taking an example of a four-wheeler car now. So and for a car, when you're having an electric vehicle and comparative to IC engines, so what is the difference? I've put it into the three parts actually. Three contributing parts that actually help you to understand why there is a need for shift. So if you're taking the moving parts in electric vehicles, it's hardly 20 to 24 components. I'm talking about a car. So it's a four-wheeler, like with a lot of other components. Then wearing and you when you're considering a lifetime, because when I told I have a car that has 1.35 lakh driven 1.35 lakhs, and I would say that my engine is really good. I mean, like it still runs very smoothly, and you have components that are still smooth. So that's where your basics of engineering comes into picture, like material properties. Aluminium, consider like when you're talking about steel and aluminum has a lot of wear. When it undergoes a lot of friction, it has a lot of wear. That is the reason if you consider brakes, uh, see, we talk about efficiency and lightweight, but even in Formula One or even in like high-end cars, companies like big brake manufacturing companies like Brembo still uses high-end steels, or now they're coming up with Kevlar, carbon fiber. That's a highly costly, but companies still use steel because that is where your key basic point remains, is like the material property of it. So steel doesn't wear much on a frictional encounters comparative to aluminum. There is always a wear, obviously, but comparative to aluminum, there is always aluminum really wears in a very small frictional contacts as well. But we also talk about other property of like other thing when you go into manufacturing called hardening process. So that again comes back to your basics. So what you do is you build a brake with a steel and you harden it. Hardening always helps you to improve the material properties of it. So that's why you see brakes have been run for like 1 lakh kilometers. Still, you don't find it any. I mean, you don't have any problem. But comes down to aluminum where you can't even run for 1,000 kilometers. So yeah, so that comes into the varying parts list. So, and also if you're talking about varying parts in a system constituting of only motor and engine, so you do have less moving parts in the engine. In the electric motor rather than an engine, which I'll be discussing more deeper. Now coming to uh, the main difference actually. So with electric vehicles, it's always the high torque in the initial RPM. So it's like you switch on the bike or car and you press your throttle. Here you don't need to have a gear. I mean, you always have a gear, but with electric vehicles, most of them they don't really suggest, or they don't really use it. It always accounts to your efficiency. So that's the reason most of the times you avoid gears in EVs, especially with two-wheelers. So yeah, turn on the bike and press your throttle. So you just jump off to a start. You always feel like you are driving an Formula One car. I mean, even with a two-wheeler, I'm telling, because that brush, that amount of rush it gives, that amount of rush only comes from an electric motor. Comparative to what you have in engine is, you always can build a high torque at initial RPMs, but always there has been, you can't jump to a fifth gear directly. You could you can always know. And with you could see like CVT engines, continuous variable transmission engines, like Activa. I'm talking about real world applications like Activa, like any other scooter applications. You could see you can't give a sudden torque, you can't suddenly go to that high. Consider if I have to put a race between electric two-wheeler and like I'll consider electric scooter and an Activa with the same specifications. My electric two-wheeler would run very fast, I would say. Well, like, comparative to Activa. I mean, it's not always about the speed of it. It's always that initial torque. So I'll tell you the reasons anyways. But so that is the main difference that you actually get. Now, battery efficiency. As I was talking about my first point during the first session, it's that electric electric vehicles can achieve an efficiency more than 90-95%, and we have seen numbers like 94-95 as well. But when it comes down to IC engines, the efficiency drops to 36%. Whatever the data that we have got is an average is 25% of IC engine efficiency. I mean, I'm talking about something that goes onto the wheel, not onto the engine. Engine you can achieve almost like 47-45%. But when it comes down to the wheel, because you can't put an engine to the wheel, right? So that's where what you have to do is you have to create a drive system. What you see in typical two-wheelers or four-wheelers, or most of you seen bigger trucks. The comparison I'll give you basically. The first one, you are most of your times for the two-wheeler, you have seen that it is always driven by a chain driven. It's always a chain driven system, right? That is with the electric two-wheelers. I hope you have seen in the cars, even in the cars, you could go with shaft, and trucks also shaft driven systems. So the shaft driven systems are quite efficient, but not considering not that you're using a steel body. The shafts are always steel, made of steel. I mean, as of now. So again, it comes down to your material properties. So nowadays people go with carbon fiber and Kevlar, but again, it all depends on the cost. Comes down to cost. So what I suggest, what I'm making the point here is, there is always extremities that you can build. I mean, like I could say that I can build a plane, electric plane, or I can build an Iron Man suit as well. I mean, like with all the things that you have. So and it all comes down to what are the factors that you're contributing to, like what exactly you're building out this product to a user, to someone who is running it on the road. So it has to be a combination of lot of factors. So that's where what companies do or what they do usually is it is always a balance between what factors, what specifications that you want, what is the cost of that specification, and who is the end user. So whenever I mean my suggestion again, out of the topic, my suggestion again would be, whenever you're learning something, it has to be a practical application. Like what I suggest is a certain important factor or a certain basis of core mechanical thing that you're learning. What I suggest is you have to find a real application to that. And just I mean, it need not be starting a company or starting an idea or starting a project or something. It always something that you can write it down. Like, for example, you could come across a question, why there is a need for for example, I'll tell you, when we are talking about shaft drives, why there is a need for only steel. Because now you have knowledge of this material properties. What I suggest is, you know that how the shaft runs. So what are the stresses that behind that shaft. So break it down to singularity. What I suggest is break it down to singularity. That's how components are being built. Like for example, the shaft again. So what are the stresses that it goes through, and which materials applies to this? Which material satisfies my the required application based stresses? Like for example, I have a certain value of stress. What are the materials I can match up to? And then you have like 10 materials available. Now again go to the next property, you could cut down another 3, and finally it comes down to a balance between the efficiency, cost, and lifetime, and all the other contributing factors. So yeah, so the same goes to electric vehicles and IC engines. So these are the basic major difference, I would say. Like, electric vehicles, the point is it is, I would say, it is lightweight. it is it has less moving parts, it has less wear and tear. It gives you more power, more efficiency, more technology towards it. I mean, like, you could play with the technology and give a kind of feedback to the user. It's not the same with engine always. And then again, you have, like, talking about environmental factors as well. There's no pollution and all the stuff. So there are, like, I could just list out a 7 contributing factors. There are actually a lot more contributing factors that tells you the need for the shift in the electric vehicles. So basically, when I told you first to keep out the environmental factors and the cost factors, what here makes an impact is your energy part. So as I told you in my last session, for the same vehicle what we have built, 100 rupees of a petrol, 100 bucks of a petrol can drive me 2000 kilometers on my vehicle, but it drives me hardly 60-65 kilometers on my Activa, or like what are the vehicles that I have. So it comes down to cost to the user, and also you're always contributing to the energies as well. You know, most of the time, like last time, the first slide we have seen is like, we have like most we have imported more amount of gasoline than like some countries' GDP even. So that's how the thing is about the Indian auto, I mean, like, auto industry. But compare talking about the global auto. So why the shift is basically, these are the factors, I would say. These are the contributing factors. Energy is the key thing that people actually wanted to have now, and the technology behind it. Saving that, fossil fuel technology. This fuels can be used in a different applications, like different applications. Now, so that's how that is the need for this transition actually. You could go to a smarter, you're shifting to a smarter technology, you're shifting to a greener technology. And people always, there is a contradictory that people always tell that your energy from the battery is coming from hydro plants or industries or something. Yeah, there's always a, how many of you know that, we have like close to 250 or 300 charging stations in Hyderabad, out of which 100 are being built under solar roofs. And there are like 10 battery swappable stations in Hyderabad, which out of it 6 are built under solar roofs. And overall, like 2025 to in Bangalore, which out of it 18 of them are built under solar roofs. So there is always a contradictory. There is always someone who tells that this is wrong. But what I suggest is, like, what I tell is, there is this really is a form of greener technology. I mean, it actually provides you clean mobility. You don't have to really, I mean, like, those pollutants that come across, that is not really required. So that is the reason I would say would be a transition to this technology would be needed. Now let's go deep into the technical part of it. That's where our core thing. Why do we need to shift? So basically, let's talk about engine. I'll be listing out only the major components, not the everything, nuts, and not until the nuts and bolts level. But coming to engine, you do have a piston base. You have piston, you have cylinders, you have spark plugs, you have, like, air intakes. Then again, you have exhaust pipes, radiators. Then you have shaft drivens, and like, what they say is, close to, out of this 150 moving parts, close to 100 are only present, like, in the engine itself. More and more amount of moving parts. As you know, how you must have heard of, moment of inertia. inertial mass, right? What you currently are is a normal mass. What you are sitting is a normal mass. Inertial mass is that defines the state of your mass. Look, for example, now when you are sitting, it's a inertial of, I mean, the inertial mass would be rest mass. But when you are moving, it would be a move, like, the rotary mass, like, every component that undergoes some sort of, like, rotations or like movement, it has a different mass. What mass is it? Like, many times when you're on a flight, you're taking off, you suddenly feel weightlessness, or when you're dropping, when you're landing, you feel like kind of heavy. That is because, like, the gravity force, g force, which you can call. So this contributes to the efficiency of it, basically, I would say. Like, every moving part actually adds a mass. Like, it's like, consider you're talking about a mass of an engine as like 10 kgs, for example. Mass of a piston. Let's talk only about piston now. So mass of a piston, be it like 10 kgs. Now, when it is moving at a 13,000 rpm or 10,000 rpm, consider, like, which you usually encounter in bike cars, mostly. So when you're moving in a 10,000 rpm system, it actually adds to this 10 kgs plus that moving mass. So what happens now is, every time you're a part that is moving goes into a higher inertia, like higher speeds or higher inertias, what happens is it actually increases the mass. And you always know that more the mass, lesser the efficiency of a system. So that's the reason why you have to cut down more and more number of moving parts. And that's the reason they say that more the moving parts, lesser the efficiency. More the contact between parts, lesser the efficiency. So that is the reason why engines are lesser efficient than electric motor, because electric motor has less than 12 moving parts. Like, I would say even lesser, actually. Like, if you are not considering two bearings as an individual part, it's just only the shaft that you could see on the picture, outside shaft that is projected out. Then you have inside bearings. Then you have stator that is already, I mean, stable. You don't have to consider it as a mobile part. Then you have a rotor. Then you have another bearing system that actually goes into the whole thing. I would say, like, when you're talking about a car electric motor, a four-wheeler electric motor, it would be less than 10 to 12 parts. But when you're talking about an electric two-wheeler, it's less than 6 parts, actually. So the lesser the moving parts, lesser the inertial mass is, and higher the efficiency. So that is why you could see that there is a, like, even the sizes are bigger. The casing that you make it with casting process, the aluminum, the battery case, I mean, like, sorry, the engine cases, or like sometimes you make it with forming process using steel. So these cases are rather heavy again. Now, when you're coming to motor casing, what you see here is an aluminum casing. But if anyone have noticed, or if I've mentioned a specific point during my first session, that we have built a company using glass fiber and composites. So whatever we have built is using glass fiber composites because of the cost factor of it. You could always build with carbon fiber and Kevlar, which is not even can go out into the market because of its higher cost. But what I could say is, with glass fiber, I'm getting down an efficiency of more than 4 times. With aluminum, I just had 2.7 times or something. But now with carbon fiber, or with glass fiber, I would say it would be close to 4 times, because glass fiber density is close to 2000 kg per meter cube, and where steel casing would be something around 7800 kg per meter cube. So you could see the comparison. Forget about the inertial mass. Even in the initial stage, what I'm trying to compare is, we are taking out the mass of the system. That's where the higher efficiency comes in. So that's with the engine part. Now you already have this what do you call it, drive system. Then I would say, like, the shaft drive in the cars, or chain drive in the electric two wheelers. Now, but you could just question me, obviously, like, isn't it the same in electric vehicles? So yeah, that's how the difference electric vehicles make. So for an four-wheeler system, when I will be discussing about the frames, I'll be showing how electric motors are integrated without the shaft system. You must have known about you must know about this differential that you have in cars. I just run a small basics if to the people who doesn't know. Basically, when you're turning in a corner, you would see that the outer wheel takes more longer turn than an inner wheel. Then how do you because if both wheels are moving at the same speed on same torque, it doesn't give you traction, right? It doesn't give friction on the road, or you would never end up taking a circle, or you would end up taking a longer circle. So that's where the differential comes in. Differential actually distributes the power to two different wheels. So this is just a small brief about differential. So the key point here is you don't have to use a drive system to run a electric four-wheeler. Here it is always a differential that is clubbed onto both the tires. And in case of electric two-wheelers, you could always use a hub motor. The rear wheel of the vehicle, you can actually build a motor around it actually. So you don't need a drive system. So the hub motors are like really around 90% efficient. There are like cons again. I mean, like, I'm not saying everything has only positives. There's also negatives because you go into more deep into vehicle dynamics part of a two-wheeler. You don't have to have a lot of unsprung mass. That is like lot of load on the wheel. So when you have a lot of load on the wheel, rotating wheel, again, it comes down to the inertial mass I was telling. So motors typically weigh around 3 to 4 kgs, right? So what happens is when your rotation is solely in the wheels, you know this the one you see in the picture has a shaft, and the shaft will have a sprocket, and the sprocket is being connected to a chain drive that drives the wheel. This is what an engine does, and also a motor does. But when you're putting a hub motor, and I mean clubbing a motor onto the wheel directly, the key challenge would be the inertial mass, because now initially the weight of the wheel was 2 kgs. Now with the motor, the weight of the wheel plus motor has become 5 kgs. Now my inertial mass is quite more higher. I am saying, I mean, what I'm trying to tell here is everything has positives and negatives, pros and cons of it. So, but comparative to electric vehicles, there is no. I mean, like, the efficiency is very high for electric vehicles comparative to the typical IC engines. So what factors contribute to the shift is these are the factors that really contribute why there is a need to shift to electric vehicles. This could be a real efficiency booster, energy booster, and also other contributing factors like it hardly consumes, like it hardly consumes your pocket, like it's like for electric cars you could run 1,000 kilometers on a 5,000 or 2,000 rupees budget, uh, but not the same within fuels. Then there again I was telling about the environmental impact it gives you. There's no scope of like pollutants and all. So yeah, and that's not the whole thing. Here comes a key part actually. So when you don't have more moving parts, it doesn't go through higher wear and tear. So when it doesn't go to higher wear and tear, you don't need a frequent service part. So your vehicle need not be serviced uh, on a every time basis. So I note this point because people, companies brand to tell you that they'll service your vehicle every 2 to 3 months. Electric vehicles, actually, there's no requirement at all because these have very less moving parts, and the point is it does, like the factors that contribute to this building of an electric motor doesn't need you to service every time. So service part is not required. This we are talking about in a normal user's perspective. So these are the reasons why there is a need for shift to electric vehicle, and the technical reasons we've already discussed about the efficiency part and what are the factors that contribute to this efficiency. So yeah, before I jump into this really deep into this electric vehicles, just let me know if you have any questions for the next 1 minute. Yeah, seems like no questions. I hope everyone's clear with what we have, what the session is about. And you can definitely raise a question at any point of time. You could stop me in the middle as well. So, but I hope it has been clear that, like, why there is a paradigm need of shift to like electric vehicles completely. So yeah, so I'll just go deep into this electric vehicles now. Yeah, so talking about the ecosystem, like, what exactly does an electric vehicle's components include, or what exactly does a whole electric vehicles as an ecosystem include? So, so if you're talking about electric vehicles, it's like it runs down to this way. So, you know, we already discussed about battery part. Something that runs the vehicle, right? Now, what has to power it? It has to be a battery that has to, motors are driven by batteries. So it has to be driven by a battery. So that is the key, another key component of an electric vehicle, EV battery, and this motor. Then again, uh, you have other components in a motor as well, like motor controllers. When I told about differential sending, I mean, when I mentioned about a point about the differential giving difference, sending different power to different wheels. So the same way, you have this motors, electric motors can be customized. Customized, what I mean is, it's always like, you could play with the motor, you could play with the software and control the hardware in a very easy manner here. So that's one advantage that gives that electric motors give you. Can't we do that with engines? So that might be a real question actually. So basically here the point would be, engines are constrained to efficiency and powers. So when I told my point here, when I've mentioned my point, if you could see the IC vehicle part, high torque in a specific RPM range. So this has to be pre-tuned, and you with the electric vehicle parts, you could connect this whole. When I told about motor being controlled by an electronic system, what is exactly is a controller, right? So what you do is you take the positive and negative terminal of a motor, which I'll be showing in the last half of our today's session. I'll be showing you a complete battery, a complete motor, or a complete dismantled motor with individual parts. So you would be much more clear about during that session. But to just put it in a way, so what happens to a motor controller is, like, you connect an electronic system to a hardware. Now what happens is you have an absolute control of this hardware with your software. So that's where the electric vehicles stand out. You could do anything with this part of this motor, just running through a software, just playing through the software. So that is one other key component of an electric vehicle. One is the motor, second would be the motor controller, then again the battery. So now let's discuss the battery. As I told, would be lithium-ion cells stacked together. As I told that when you're taking a small remote and cells and stacking together, and again I'll be showing you a battery pack, a little in-house manufactured battery pack during my last session in the video of dismantling of a motor, and also the battery. I'll be showing how this electronics really affect the performance of this electric vehicle. So coming back, so that EV battery is one another key component. that actually plays an efficiency part as well. So again, when I told that you have individual cells tagged, now this has to be controlled through an electronic system. Again, that is where you can play with this electronic system. So you could really tune it at any point of time. You could tune it in such a way that you could see the right wave. For example, you all know that efficiency or mileage, to be put it in a vehicle terminology, mileage. So upon, like, if two people are riding a vehicle, I mean two people are with a pillion rider, you always see that there is a drop in the mileage. That is because you are adding more and more weight. The same way, but you don't have control over the system. So what you can do with electric vehicles is, if you want to achieve for example 100 kilometers of mileage through, you call it range in electric vehicles. So if you want to achieve that 100 kilometers range, you could tune your motor in such a way. You could tune your motor to control your speed and torque in such a way that your range remains the same, but there's a slight drop in the speed and torque of it. Or you could even keep the speed, but you can reduce a bit of torque. So when I'm telling you this, you could play with the system. So that is how the electric vehicles are usually. I mean, what if I told you that you could do all this on your phone? So that is how you could take the technology up to. That is how you could take the electric vehicle technology up to. So that is more of an IoT, like you are connecting the whole hardware to a software. You call it digital twin. So you're twinning the whole software and hardware part, and putting it at a specific point called cloud. So where you can operate all those stuff. So I'm talking about the more hardware part. You are now, we have motor controller, battery, and battery management system. You call it BMS. So which is another key factor. So obviously, for all these things you need to for all these things to run, you always needs to charge the vehicle. So I would say, like, for charging, there's actually we have public points now being introduced in, like, major cities, where you can just go and plug in directly, and it charges your battery in less than 3 to 5 hours, depending on the vehicle. Then again, you have home charging systems where what we have developed is, like, you could just take out the battery, carry it just like your phone, and charge it, and just we can put it back into the vehicle. So I mean, there are ways to do it, obviously. So, and who are the? I mean, like, let's talk about the business perspective of it. Like, end point is, we as a customers, we can do it. There are a lot of other segments, like, people who are operating in a who deliver you food and groceries, like Swiggy, Zomato, and all. So people there using those kind of vehicles can be a much efficient way of doing it. So there has to be a purpose when you're building a component, right? So I mean, like, these fleet, you could say, I've mentioned here, this fleet fleet is a different people, like, specific set of people for a different set of application. So they do use it. And now, if you could see, I'm not sure how the things are in with tier 2 cities, but like in Hyderabad and Bangalore, and, like, you must have seen the electric buses also. So yeah, so what I'm trying to tell is, like, the shift is slowly happening, and these are the main things that contribute to this electric vehicles, and these are the key factors. Sorry, these are the key components that are in an electric vehicle, actually, and these are the end customers. The reason for putting both technical and business points of it is, like, there's always some opportunity that kicks at any moment of time. So you could build a vehicle for an fleet. You could build a vehicle for a user. You could build a vehicle for someone, like, internal applications like resorts or industries to travel in baggages. You must have seen airports. So airports have baggage handlers. Baggage handlers can be electric, and then you have industries moving machinery. I mean, like, you have to send one part to other place. I mean, big industries have bigger assembly lines. So to send that one parts to have, you can put an electrical system. Then you have normal user. Then you have public transport. Your metro is always using electric mode of communication, and you now there's a slowly shift in buses as well. So what I'm trying to tell is like, not only knowing the technology, but knowing the end application would help you to build this technology. Whom exactly are you building into, and what exactly are you building? So that is how I'll be showing in the next these things. And these are the basic components that actually come up in an EV. So yeah, as I mentioned, it could be anything. It's an you can start right from electric bicycle, electric mopeds, electric scooters, electric motorcycles. Then you have electric segways, like a two-wheeler that is self-balancing. You could see in the image. Then you have electric four-wheelers, not only cars, trucks. Then again buses. Then again, you could see that autonomous industry applications. So trucks, everything like you could make it, you could fit it anywhere. So that it has various applications basically. So that's how the applications of for an electric vehicle. So yeah, go what are the different types of basically the vehicles. I mean, like I put it into the electric vehicles, I would say terminology. So electric vehicles, I'll talk you about like more about first. Let's when you're shifting from IC engines to electric vehicles, I'll talk about that way in the reverse order, I would say. So now whatever the cars that we had 3-4 years back was completely engine based, right? So what is the next step to efficiency? What people have done is uh, they have built a vehicle. It's a hybrid vehicle. It has an electrical system, like for example, there would be an engine. Definitely there would be a engine and a motor as well. Now the engine drives, I mean, like engine charges the battery, then battery fuels the motor. So this is how it is done actually. So is it efficient? Obviously it's much more efficient than what do you call the exist IC engine vehicles, but you're using more number of parts. But when it comes to users perspective, it is like there is a slight increase in the mileage and lesser pollutants, I would say, because to charge a battery you don't require that amount of fuel or that amount of pollutants that release, rather than driving a vehicle, right? So for example, I'll give you a small example. I'm sure everyone are aware of alternators in the cars or bikes that you have in the two-wheelers and four-wheelers, right? So you know that why we don't charge a battery that is present in the existing IC engine two-wheelers is this alternator is being built to charge the battery, recharge the battery again and again and again. So the same way, I mean, you could see that it is not there's not a lot of power consumption, right? So there's only limited power consumption. So when you are running I mean, it is charging your battery, and battery in turn drives the motor. The same way this plug-in hybrid electric vehicles are. You have to put the fuel in, like you have to pour the fuel into the vehicle, which only charges the battery, not your which doesn't run your vehicle. So you could see that running a whole 1300 k's car by a engine is different or charging your battery. So here you could see that you don't need a lot of moving parts. Now you are eliminating your shaft drive. So we are back to engine efficiency being 36 or 40%. You got my point? Like we discussed, for example, here we discussed about engine efficiency. You could see the last point in the IC vehicle part. So engine to wheel efficiency is 25%, because there is a loss of efficiency in the transmission system, in the shaft drive, in the gearbox that you're building. So gearbox to transmission, transmission to wheels. So here, when you are using gears and there's a frictional contact between the gears, then again more moving parts, the efficiency is dropping from 36 to 25%. But when you're charging a battery, you don't require a gearbox. You don't require a shaft drive. You don't directly need to power up this to the differential. Now you're eliminating, I'm not saying three moving parts, three major systems that contribute to the efficiency, that decrease the efficiency. So whatever the power that you're getting from the engine is being only put to charge the battery. So you could see there is a drop, really a drop of components, which always means that there is an increase in efficiency. Now coming back to the second segment, now the motor is being put in the differential, like uh, in the differential segment. So motor acts as a differential now. I'm not saying that motor is being connected to a differential. Now motor acts as a differential. What happens is you are eliminating the need for shaft, gearbox. I mean gearbox in the engine again, but you need to have a small gearbox in the motors as well. So that part, what it does is it eliminates the drive system, which accounts your 10 to 12% of improving the efficiency. Now again, for this is the first 10 to 12% that we have decreased, converting from an IC engine to hybrid. Now let's go on to the second point, which is I have to drive an 1300 kg car with an engine, which is like I have to use lot of power to drive a 1300 kg car, but I need very much less fuel or less power to charge the battery. Now, second point that increases the efficiency factor is my weight. I'm not driving a car, but I'm just charging the battery. So what happens here is you see a sudden increase of at least 20 to 25% of the whole system mechanism. Obviously, I mean, the whole thing comes to 50-55%, but you have to account for the other factors as well. You can't just tell that, oh, okay, I've put on a battery and motor, my efficiency will increase. But you have an engine and you have a motor. So considering the weight of a gearbox, drive shaft and all, and the additional weight of battery and motor, there's a slight drop of 5 to 6% in the efficiency again. So when my plus 10 to 12 without gearbox and drive shaft, and plus another 20 or 10 to 15 without my without having to drive my vehicle, which I accounted for 30%, close to 30%, with my efficiency coming to 50-55%. But there's a slight draw, there's a negative of minus 5 to 6% because of the additional weight. What happens here is I'm getting an efficiency of 40 to 49 to 50%. So where my mileage of 20 or 22 kilometers, which usually companies promise, has gone to 45 to 50 kilometers. Now that is what you call hybrid, and that is how you have come up. That is how there are vehicles like Toyota, Toyota Camry, or like there are other companies as well. There are companies that are coming with CNG now. CNG is being powered by like other factors as well, like CNG plus battery, engine plus battery. So there are companies that are coming up in here, and you could see hybrid vehicles such as like CNG in CNG plus engine in what do you call it? Yeah, a lot of cars, like old cars also, CNG plus engine. But this CNG plus engine doesn't give you any advantage. It only increases your weight, and the mileage is typically the same. There's no increase in the efficiency because you're adding your weight, and CNG doesn't help you at all because CNG again relies on the engine to run. So engine to run the vehicle, not to charge anything. So but there could be CNG plus battery, just like CNG, you're just putting a gas in, and uh, which runs the engine, which in turns runs the battery, runs the motor. So you could add different hybrid systems, right? So that is how it is. But so this is what is about the hybrid system. But I'll talk more about hybrid for the two wheelers also. Now, quite a good companies in India are coming with a hybrid two wheelers, like having both engine and motor. It's a good system to have. We are always worried about charge, right? When I've mentioned about my vehicles where we are only giving a 65 kilometers range, but our application is different. But you never know what the end user applies it for. He always feels that 65 kilometers is very much less. Be it a 5 kilo, be it his commute being only 5 kilometers, but it's always less because he always have that anxiety of range. What happens if my vehicle runs down of a charge? Which is not the case in our petrol-based or fuel-based vehicles, because I can always I can always get the fuel in the next 2 to 3 kilometers. But that's not the case with the batteries. So that's why hybrid vehicles, people are quite a good companies in India are coming with, like, I would say very few are company coming with hybrid vehicles, hybrid two wheelers as well. The mechanism remains same. Always have your engine and a battery and a motor in a two wheeler, built in a two wheeler itself. Sounds like a bit of heavy, but at the end of the session today, you won't see, you would see that which it isn't the case, because when you are using an electric two wheeler, there's always a change in the components around it. It's not only the thing that you change engine or exhaust or all the other components related to engine, but when you're putting an electric, when you're adding electric to the two wheeler part, what you do is you could play around with the frames as well, battery frames and everything as well. So, which we'll be discussing in the next session about the frames and all. So coming to, like, we've already discussed about plug-in hybrid. Then let's discuss about. We've already discussed about all electric. So you would just remove the engine from the front trunk, the drive system, the gearbox, and remove the connection with the differential, and completely remove the differential as well. Now you put a system with a motor at the rear wheels, or you want a four-wheel drive, always you can put it in the front wheel as well. Just typically talking about a two-wheel drive at the rear. So you are removing the drive shaft and gearbox there. So basically what it does is it actually improves the efficiency, which we already discussed. So that is the fully electric part and the plug-in hybrid parts. So yeah, this is just a illustration, I would say. What happens is, like, you have this engine here. You have you could see. I mean, if you could see the vehicles, the first part here is the engine, and the rear part there is the motor, and it is being driven by the battery. So there is mild hybrids. There is, like, mild hybrids. What they help is, if you remember, we have discussed in the first session that engines don't have an initial RPM, right? So when engines don't have an initial RPM, because when you're trying to have an initial RPM, initial boost, you are consuming a lot of power, which petrols or any fuels doesn't give you. So the scope of hybrid is, there are two ways: mild hybrid, full hybrid, right? So mild hybrid, what it does is, it whatever the companies or whatever the two wheelers that you can do mild hybrid is, you can run the vehicle until 30 kilometers per hour, or 40 until 40 speed with an electric motor, then shift to an engine after you reach this 40 speed. So it's like, I am both saving my, because people say that it consumes a lot of, you must have your parents or your father typically, who must have learned you how, how to drive your vehicle or something, must have taught you, sorry, to drive your vehicle. So they would definitely tell you don't drive the vehicle in the first or second gear, and you could also see that there's a lot of fuel consumption over there. So because it requires it requires a lot of initial power to move from an inertia of mass to inertia of rest to inertia of motion, right? To attain that, you need an external force. So that external force requires a lot of fuel. But what if it is provided by a electric part? Because electric doesn't consume a lot of power in the initial stage. Though it consumes a power, comparatively there's a very vast comparison. Like here you could talk about 70-20, 70-30. So that's how the mild hybrids run until initial torque. It gives you just an initial push, and you always know that basic physics, like body in motion is easy to continue in motion. Now if I get that initial push from electric, I need not consume higher fuel in the initial phases. So my hybrid part really works with efficiency, so my mileage would automatically jump from which is like considered in bikes, which is like 50, 60 to 90 or 80 to 90. So that's how the mild hybrids help. Full hybrid, again, we have already discussed. Engine just powers the battery, and battery in turn runs the motor. So that is how mild hybrid and full hybrid are determined. So plug-in hybrids, it's like uh, these are like systems, actually complete systems that you have, like they switch in, actually plug-in hybrids. You have like large batteries when compared to full hybrids, actually. So the point is, you could actually, as I told, like you have both the things. You can put a fuel, or you can run it through battery motor. So the last part is battery part electric vehicles. So it runs to lithium ion cells completely. You only have battery and motor. So that is called BEV, fully battery electric vehicles. Now last part is FCEV, like fuel cell electric vehicles. So when I told in the first part, like in this during my first this thing in this session, that different type of batteries are there, like it all depends on what application that you want. Like for example, you might have recently heard a news of Hyundai coming up with a hydrogen powered vehicle. So it is much cheaper, much more efficient, much more greener, but it has its own challenges, like because hydrogen can't be stored at a room temperature, or can't be stored, it has so much of volatile properties and vulnerability with that. It's just that any amount of thing can really cause a damage to the whole engine and whole system itself. So I'm just giving a small example. So Hyundai has come up with a hydrogen-based vehicle, which it can run up to 1,000 kilometers per one tank of hydrogen, I would say. Now you can't call it a charge. So one tank of hydrogen can give you 1,000 kilometers. So those are fuel cells. It need not be a hydrogen. It could be anything. Like for example, I have like people are talking about aluminum air batteries. You have aluminum as a fuel now. Solid state batteries. This could be the future. This could be the coming future, using sodium, because sodium is always available in India. We have like a lot of seas and all. You could extract sodium like easily. So you must have also seen that I mean, like talking about the why fuel cells are important, or does it really have a future? You could see that one of our own entrepreneur, like Mukesh Ambani has recently invested in a fuel cell company. It is close to 1,000 crores. So it's like solid state batteries. So solid state batteries doesn't have this vulnerability as lithium ion batteries. So solid state batteries have high energy density also. So it all comes down to energy density. Energy consumed, like I've mentioned here clearly about energy density, like watt per watt, like this is part of like wheel efficiency. Like, it all comes down to how much efficiency that you can build out of a fuel cell. So yeah, so these are the new things that are happening in electric vehicles. Mild hybrid has always been there. Full hybrid, uh, Toyota Prius is one good example. It is the most sold car, most sold hybrid car across the globe. So it's been there from past 7 to 8 years, 10 years, I would say. Plug-in hybrid is like very less, very less. But battery-powered electric vehicles have been. You could see that now it has been like you have good companies like Tata coming up with Nexon EV, Hyundai coming up with Kona. There's good models coming up with a battery-powered electric vehicle. Fuel cells, I would say there is not much of development happening so far, but these whatever the vehicles that are on the road are just in the prototyping phase, or like you would say early adoption phase. They're testing out with few people on how this thing runs. So this is about like how different type of how you could use the technology of electric vehicles to run a electric the technology of that electric vehicles battery and motor to run the vehicles. So these are the types of electric vehicles, I would say. So yeah, going deep into like as I told, like the path. Just give me a second. Yeah, I'm sorry. So basically, as I told, what are the components that you see in an electric vehicle basically? So battery and motor I've already discussed. Then you have battery pack I've already discussed. Sorry, battery management system is already discussed. Then again you have motor controller you have discussed. So the same way, engine has a radiator thing. This when I told that when I told that the power is being drawn from an individual cells in a lithium-ion battery. I know that it might be a little confusing here because it's more of an imaginative thing about talking about the batteries. But what the reason why I've put that battery part to the last is you could always you could always keep this as a core thing. I mean, like you could always see that where exactly the application is, and in the end, when you see this battery packs, you could easily understand why there is so much discussion about battery and an electronic system that is being connected to it. There is so much vulnerability about this batteries because the IC engines we have been using this batteries from past 10 to 2 like not 10 to 2, it's like close to 100 years we have been using batteries, but there was never a discussion of battery being caught fire. I mean, some cases, rare cases keeping aside, there was never a discussion of battery being a problem. But when you're talking about electric motors, why is this battery being a heavy discussion in this? Why is this talked about so much vulnerability? Why is being talked about there is a need for an electrical system to monitor or to control this battery power? So these things you would definitely know in my final session of I'm sorry, in the battery packs in the development. I'll be showing you the electric motor and the battery packs for a two-wheeler. So it is same as an engine. Like you always need a cooling system for a battery as well. Just batteries get heated up. Oh yeah, good example. Forgot to tell you this. You always have when you're charging your phones. I mean, not talking about most phones, but some phones actually get heated up, right? So that is because the battery is subjected to thermal runaway. There might be some. I mean, like it's not always runaway. It is like battery is being heated because be it the load. They always tell that don't use your phone while charging. I mean, not these days at least because they already have battery management system. But even today, you could see that some of the batteries get heated up while or you when you're using more and more applications like you're playing audio, running Google Maps, using camera. All this together, what it does is like it improves the load on the battery, and suddenly it gets heated up. So the same way you have load on the vehicles, which is already usually considered by the manufacturers while during the design itself, but external temperatures are something that are out of control. I'm design for example, I'm designing battery for Indian conditions, or like one good example I'll give you. It's nothing to disrespect any company in such a way, But what I can give you a good example for this is Ola Electric. You must have heard about the lot of buzz that is happening around Ola Electric, right? It's like, they've literally kind of created a huge marketing stuff, and also vehicle looks promising from outside at least. So I'll tell you a small story about this Ola Electric. Yeah, we are always grateful to the Ola cabs. It's a real good solution, but this is to specifically related to Ola electric bikes. There's a small mistake that could really damage your whole thing that you have built. Is the bikes that the bikes that you see in an Ola electric vehicle, is that these vehicles are being built in Netherlands by a company called Itergo. So what Ola has done is just acquired them. Like, you just buy that company and put that same technology and bought the same technology and built here in India. It's like they have literally bought the whole design and manufacturing things and built here in India. A few early things tell that, few early rides tell that your battery gets turned off. The only reason is being, I have my Netherlands driving conditions being minus 20 degrees to 25 degrees max in Netherlands. But here what we could see is the average temperature where you run is 25 degrees, and and things gets worse in summer actually. When the temperatures go up to 50 degrees, and places like Rajasthan or even in Telangana, there are some places where it touches 50. So what happens is, this is a normal phenomena. I'm not specifying it to a specific company, but so far the challenges have been, that is how the manufacturer cannot guarantee you. I mean, usually, I'm not saying guarantee you, but manufacturer cannot do such kind of things. It's like, factor of safety is always a key thing when you're developing a component. But what I'm trying to tell here is, so there are things such that you can't control. Like, companies design the factor of safety of more than 2.5. With electronics, you use more than 2. With mechanical systems, you use sometimes in battery and motor related, you use more than 2.5. So the factor of safety. But sometimes, these are the factors that really affect actually. So you could also relate it to your engines when you're driving like more than 1,000 kilometers, or when you're driving continuously more than 500 kilometers or something on a long run, your engine gets heated up. The same way, there's a thermal thing that also affects the battery and motor as well. There's always a cooling system which is same as a, you couldn't say it's the same as a battery, because it runs by a radiator and it has a different cooling applications. Here, I'll be showing you more in my last session during how the battery cooling is done. So again, you always have a electronics, then you have a more then you have a last part is the charger thing. So what happens is, like, you have for four-wheelers, you need to have an onboard charger. So onboard charger is like, the charging system has to be deployed in the vehicle itself. I mean, like, for example, in our case, we don't have a system that has an onboard charger. You need not have it, because you are just removing the battery out. So there is always a scope to charge the battery outside. So these are the key components that are in the electric vehicle. I have listed out as much as possible. The rest of it is same as what you see in a typical IC engine vehicle. So that is about the battery components in the electric vehicle. So for a two-wheeler, yeah, I've listed out my vehicle itself. So this is something that we have come up with a different application. So we are launching this product as well. So you have seen my batteries under the seat previously, but now we have built a system, complete rugged system, where when I mentioned previously, my efficiency has gone from 87 to 92. So this is because of this system. We are coming up with a belt drive, first of all. Second thing, battery and motor integrated towards, so that there is no drop in the voltage of wires. This might sound so much. I mean, like, even does the wire length depend? Yes, absolutely. The signals that we are sending is at a micro level, and the time that is required to receive that feedback is at a micro levels.
So that's the reason we have completely put the electrical system under this near the battery and motor itself at a single place. For two-wheelers, it's not that complicated as that. You could see motor and battery, controller and BMS being built there itself. You could remove the battery anyways. Most of the times, depending on the application, whether you need cooling or not, it depends on the application. In our system, we didn't really require cooling because it was completely exposed to air. Here, air cooling was much more than enough. So again, I would say the heat transfer was really, I mean, heat transfer properties of this aluminum casing. Material and heat transfer properties were really helpful. Actually, you could see with for plastic, I was I was really confused between like which one to go, whether to go with plastic or aluminum, uh, because aluminum gives me a structural stability as well, and plastic doesn't give me. Again, aluminum heat transfer rate is quite good, but plastic doesn't have. Then, but again, plastic is much lighter than aluminum. Then again, that comes down the compromise between which factor I have to choose. Then again, aluminum casing involves casting process, which is lot costlier than what you see injection molding for a battery used with plastic. So, what I'm trying to convey here is, these are the factors. These are the factors that we have discussed during this session upon Rana sir. That these are the factors that you need to have. You need to understand every one and out there. With a small battery pack casing, we had to design. We had to go with a lot of factors, and waterproofing again. With casting, you are making it as a single part. For single part, the waterproofing is very much simple. Now, other solution is like when you are using aluminum, you could use, I mean, like for example, if you're seeing the bike structure here, the two pipes that are coming here, our next idea is to integrate or weld it to the integrate the battery into the structure itself, so that I don't need to have a supporting structure under that. So what I mean, I'm throwing a small example. I can just weld these pipes to this aluminum casing. So there comes by material removal, right? There decreases my weight, there decreases my manufacturing process, there decreases my material requirement. So it all comes down to whether you know this manufacturing process or not, whether you know the material properties or not, and what is the application. And so these are the factors that contribute, even though, like, when you're designing components either for an IC engine or a electric vehicles or any beat any. So I haven't gone much into individual parts because this was just an introduction part. The next session we would be talking about frames, how the electric vehicle frame differentiates from a two-wheel. I mean, like from an IC engine frame, be it in electric two-wheelers or electric four-wheelers or be it anything. So that would be the first discussion after a small break. But this is just a small brief about electric vehicles. What are the components and all? Then again, I'll be discussing about motor and battery as well. Other electronic components. I'll be showing how this actually works, how this thing actually plays a key role in I mean, like how this technology could be much smarter compared to IC engine technology. That individual parts will be going in the next session. Next would be the frames, then would be the battery and motor. So yeah, I was telling you about the components. Like, battery itself has a lot of components. I've just put inside components as well. You could see, as I told, a small remote battery. If you could remove the outer insulation casing, you could see this. These are the components. You would see like cathode, anode, separator, electrolytes, and all those stuff. So yeah, that is with the battery and drivetrain. You have motor, controller, and other components as well. Like, drive system again. You have chassis and body parts like tires, wheels, brakes, suspensions. Then again, you have chassis, seating system, steering system, drivetrain, everything. So other systems, equipments, and components would involve, like, any other IoT parts that you are connecting it to the cloud, or it could be any other components as well. So yeah, I'll just conclude this session with the next 2 to 3 slides, basically. Yeah. So with why what we have learned, so what we have seen with electric vehicles so far, and why is there a difference? It be it with components or be it with technology. What are the challenges that you face? In the next session, I would also I will discuss about the manufacturing involved in electric vehicles, manufacturing simplicity. I mean, I'm not saying always simpler, but involved in the electric vehicles and comparative to the challenges that we already had in IC engines. And yeah, all these factors I would be definitely discussing. But to finally put it in why there's a need to shift into electric vehicles, or why the electric vehicles are needed, or what, or if I have to revolve around the core components or core uh, all the components combined, if I have to take 3 to 4 factors that help me to determine why there is a need for electric vehicles or what is an electric vehicle, it comes down to these 3 simple things. It's simpler, it's smarter, and it's more powerful. These are the 3 factors that determine. It's simpler because we have discussed in the first thing of the first part of the session that it has lesser parts. It has very much lesser parts, which which in turn decreases the complexity of the building, complexity of building the vehicle, complexity of driving the vehicle, complexity of manufacturing the components, and the systems around it. See, we whatever we have focused so far, it has always been an engine, drive system, gearbox, shaft, and all those stuff. And in terms of electric vehicles, we have discussed about battery and the motor and the control and the BMS, but we have not discussed about how the change in this impacts the external parts. I have wheels, I have suspensions, I have body work. The most of my weight comes through my body. So we haven't discussed the impact that it creates on the frames, on the wheels, suspensions, or brakes, or whatever, be it any component that we'll be discussing. But I would say it makes it much simpler. So this makes it much simpler. Electric vehicles makes the bodies around it, the structure around it, much simpler because of the factors that we have discussed. Second thing is it is more powerful. We've already discussed about like the power that it gets actually, comparatively, because the initial torque is quite higher. It's way compared, not non comparable even. You could say like this is the higher torque of an engine is the initial torque of an engine is very much less. So it's more powerful, and the simplicity of it, and the smarter is like I would say like I've told you about the service model that we deploy. For example, whatever the vehicles that we have in the market so far, with the customers so far, there wasn't never been a problem as long as there was a physical damage, because uh, whatever the problems that vehicle comes across, vehicle faces, we do solve it remotely. What we're trying to do is eliminating the need for service. I'm not asking you as a customer to come to service station, or neither I'm needing the need for a service station. I'm just eliminating the need for a service station. No, you're making the technology smarter. You're giving user an access to the vehicle. You are it's like I would say, I'll put it in a small thing. It's a video game. Yeah, you have all the controls of the vehicle on the phone. It's just that you can play around it. You can increase the torque, you can increase the way speed, you can increase the this thing. But when you have two riders, you can decrease the torque so that you'll stick to that limited range. Okay, it's like you're literally controlling the hardware over your phone. So that makes it very much smarter actually. That is what the technology is about, electric vehicles technology about. So yeah, this actually has to be a previous point, but yeah, this is just about discussing about chargers, which I've already mentioned. It's an onboard charger thing that we've covered across. So yeah, that ends my session, this session. So I would love to take questions now. If you have any kind of questions of whatever we've discussed, or anything about the electric vehicles, the shift to electric vehicles, the technology, everything, you could just raise it, and we can have a small discussion regarding that. Satvik, do let me know if anyone is having questions, then so that we can.
Yes, sir.
So take a small break and then come back with for the next session.
Yeah, we have a question from B21ME020.
Yeah, please.
You are allowed to speak, Mr.
Bro, thanks. Thanks, bro. My question is, you said length is matter in transferring energy.
I'm sorry, your voice is breaking a bit.
You said the length is matter in transferring the energy from the battery to the motor.
Well, I'm saying that comes as the last part. When you're trying to improve the efficiency as much as possible. Yeah, please first finish off your question.
Means length doesn't matter now for passing any electrical energy from one place to another place.
Is it?
I think so.
Aren't we sure? I mean, aware of this voltage drop that we get? Voltage drops?
Yeah, I'm little bit aware of that.
Yeah, exactly. So that is the only thing, and also the longer the wire, the resistance of the wire also creates a problem, right?
Yeah.
Yeah. So it's just that, you have to, I'm not saying about a small consumption of like, like whatever the phone consumes is less than like very less, 5 volts, 1 amps and something, right? So we are talking about 100 to 120 amps of current flowing through the systems. So what happens is, again, see, I'm not saying these are the main factors that contribute to the efficiency, but when you're trying to achieve efficiency in a most possible way, so what we have done is we have built the motor using, as I told you, material composites where we cut down the weight. So we found out that in our manufacturing capabilities, like whatever we have the capabilities, we could build a motor. But the next factor that only where we could improve the efficiency is try to cut down how much of wastage. I mean, like the energy wastage is happening. Wire resistance obviously increases the heat, right? When there is a high current flowing through the systems, you have high. You know about this equation about I square R, like resistance is inversely proportional. Yeah, I mean like directly.
Yes.
Sorry. Yeah, so you get higher resistance and more heat is generated. When your more heat is generated, you need to have a cooling system around it. Otherwise, the system won't be much efficient. Again, when you have to build an external cooling system, you're always dropping the efficiency of the system. I'm not saying that it is a key contributing factor, but it definitely is a contributing factor until like it could be like it accounts for a 2 to 3%, I could say, or until, I mean, yeah, somewhere around that. But voltage drop and resistance are the two factors that determines the length of the wiring and all. And this voltage drop is a key factor because with I'll just give you a counter thing about like this two things, like for example IC engine and electric vehicles. We do also have an option of reserve in engines and bikes, right? So where do we have a storage for small fuel capacity? But with electric vehicles, what happens is, I mean, I'm not saying when voltage, for example, I'm talking about a voltage system of 48 volts, for example, 48 volt batteries, and the operating voltage would be around 32 to 48 volts. When it reaches a range of 36 volts, somewhere around, I mean, when there is a small, when there is a small voltage dropping, which is voltage is nothing but the charge, right? So amount of charge left in the system. So when there is voltage slowly getting dropped, the amount of current it could generate is also very much less. So whenever the system's having a longer wires and longer stuff, what it does is it not only decreases the efficiency, it also halts the performance of the system. It could up until a certain level. So that is the reason a longer wiring system is not really helpful, not suggestible as well. So this could just improve an efficiency by 1 to 2% or anywhere around that, and also it could rather improve your performance as well. So these are the factors that really contribute to that longer wiring.
Thanks, bro.
Yeah.
Yeah, hello. Good afternoon.
Good afternoon.
Yeah, myself, Ravi Teja.
Uh-huh.
I'm third year.
Uh-huh.
So, yeah, in this session, as we have learned about different types of EVs like mild hybrid EVs and full hybrid,
Uh-huh.
and we have gone through a comparison between the EVs and internal combustion engines. So, we have known that from this session we have known that where efficiency comes into matter. Electric vehicles are like we have seen 80 to 90% efficient.
Yes.
So that's I think that's make more effective
Yes. Yes.
from shifting to conventional IC engines to electric vehicles.
Yes.
Yeah, and we have gone through many classifications of electric vehicles. So
Correct.
while considering the, I have a question actually.
Uh-huh.
While considering the topology of an EV, we have
Uh-huh.
different subsystems like auxiliary subsystem, energy source.
Uh-huh.
So, and actually, my question is, while while taking a four wheeler, so it has a structure of series hybrid type of motors and parallel hybrid type of motors and combination of both series and parallel,
Yes.
depending on the commutability, whether the vehicles are used in highly traffic situations or like when the vehicles are used to drive so long, it means they need high range of RPM. So my question is, for cities like highly populated cities like Hyderabad or Bangalore, uh, commutability is more, and which type of system will be feasible and will be efficient in both comfortability of the passenger and as well as the efficiency of the vehicle.
Yeah, good question actually. So I'll just put it in two different ways. So first thing is like user's perspective, and second thing is technicality of it. So see, one key thing is we do rely on the vehicles having like longer range also. So but if you're talking about the comfortability, like majorly in Bangalore and any of our metropolitan cities, the main challenge would be constant reduction of constantly changing the gears, right? So obviously you wouldn't really when you're focusing only on the EVs part, the thing would be it would be only a single driven system. You don't need a 4WD because the application would be much more what do you call, for a higher different roads and all different applications. So what happens is like single propulsion would be definitely more than enough. But these systems don't really come. I mean, like the reason why I couldn't really give you a proper answer is it all comes down to users, because there is always a discussion that comes in. If you are focused only on the technical part of it, a single propulsion, a two wheel drive just powered through rear wheels would be more than enough. It's like you're not doing anything. Just put on a first gear, I mean a gear, and you could just press the accelerator, and it's good to go. Or probably the second as well. So that is very much okay with the city commute. But when you're talking about vehicles that are being built in India, so it is always seen that we do as an users, Indian users, we do have a lot of requirements. So when companies are coming with 4WD, it's only because on a longer run we could use this application. But I would say I would suggest more of a electric two-wheelers as well. I mean, only two-wheelers would be a much more better commute for city commutes, because average commutes in Bangalore is like 12 kilometers per hour, I would say. Now, when we are doing this project with Metro L&T, so that was the reason. Our main aim is to shift more and more people from cars to two-wheelers. Two-wheelers, by what I mean is, you need not own this as a vehicle, so you could just rent it out. But yeah, so but two WD is more than enough. Two-wheel drive is more than enough, and it could be very much easier compared to 4WD or multiple motor systems. Or you could just use a 2WD placed at your differential, and that could easily drive your application.
Yeah, I got it.
Yeah.
Yeah, one more question is the batteries which we are using in EVs presently, are they recyclable, or can we use them again by recycling, or we just dispose them?
No, these are recyclable, but not 100% recyclable. Like, actually, you could use something out of it. That's all. It's like there are certain elements, certain materials that are in this batteries, like lithium or some extent. I could say out of that, when you're putting 40 to 45% of it is reusable. So people are developing systems actually. We could slowly come up with a system that could recycle this batteries actually. Yeah, I mean, that is the case with the earlier technologies, but only lithium-ion cells does not have that 100% recyclability. So it does have, I mean, like, we have to dispose some amount of it. Yeah, definitely.
Yeah, no, that was great. And actually, another question that is out of technical. Yeah, I mean, what are the challenges or circumstances you have gone through while starting and startup?
Yes, sure, definitely. I'll be happy to answer that question. So yeah, so basically, one thing is, I previously, before starting this own venture, I've all worked in an higher level, like this my another startup as well. So I was leading the technology of that company. So that gave me actually a base for that. I wasn't really involved in how organization is built there. But what I came to know about was more of an hiring process and all, because was really taking people for the technology roles. So that was the base for me. And also, I would say, like, being a part of this college level projects where we have to I mean, if I'm sure you're aware of Supra and FSC Formula Student happening at college levels. We do have our own team. Yeah, so from there, that was my own base where I found out, like, I mean, I had this thing to manage. So that's where I started. Then again, when I started my own venture, I wasn't really sure. I mean, to till date, I'm not sure about a lot of factors like taxes and account handlings and all. Yeah, I mean, like, being from, like, always wanted to work in a technical stuff, even though started a venture. So what my challenges were, like, first, to raise an initial capital, because I would say, like, things are going in a steep curve. For example, back in 2017, there was no case for funding only. I mean, like, there was no case for external fundings to Indian startups mostly. Like, you would say, like, hardly you could see one in 1 month or twice, or 1 in 2 months or something. And there were no investors clubs and all who are ready to invest in a startup ecosystem in India. To till date, there's a challenge in Hyderabad, Telangana. Yeah, so slowly, that was the first thing, but I had to raise my initial capital because I'm building a physical product. So, and to till date, only 30% of Indian investors invest in hardware startups. Most of them subject to, like, software and software as a service related startups. because here it's not that they don't want in hardware startups, it's just that it's a risk taking factors, because we are subjected to limited manufacturing. Though we say that you make in India and all the stuff, there's a real challenge in the manufacturing that we face on a day-to-day basis. And you don't have electronics. I was telling you about lithium ion cells, right? The same way India doesn't have lithium extents. India have only small extents of silicon, which is mainly used in manufacturing the electronic circuit boards. PCB is what you call. So these are like, we do have a lot of challenges in manufacturing. So once I raised capital, a little of capital from my family and friends. So that my next challenge was to find out a manufacturing. So with all these things, manufacturers being like very much reluctant to take up, you don't, I mean, these days you have come across companies that do manufacture single and 2 to 3 units. But back in like 2019, again, 2 years back, 2.5 years back, it was really a challenging, because there was no manufacturer who could make a frame of like 2 pieces to test my prototype, or make me a motor, because I have to involve casting and all. So it was a real challenging to find a manufacturer who deals with all this stuff. So manufacturing was one more challenge, and hiring was another key challenge till date we face in hardware segment, especially with electronics, and obviously the core mechanical as well. The point here is like, you couldn't really find a new talent, because this technology is completely new. It's like, I mean, we had electric vehicles back in 2012 which had a sudden stop. The reason was like, so you don't have proper, like, core electronics or core mechanical people working on the technology. So that's where the hiring process also has been really challenging. Yeah, till date, hardware startups really find challenging to really go ahead with the business. We haven't raised an external funding yet, which we are in the process, and we'll be finishing off that by April. But it's been 2 years, and we had to run through our own revenues. We had to sell the vehicles and use that revenue to build our own machinery, build our own production unit. So yeah, first 4 or 5 years it's always challenging, until you come to a stage where you have a self sustainability, or you have someone external funding. So yeah, capital, when you're building a hardware product, it's always a capital, and product related issues. When you're into a software related stuff, it's all, I mean, I'm not saying easy, because nothing as easy, like you have to start your own company and managing it. So for a software, if it's an app or a service, that you could initially start with your friends as well. So you could have, like, I would say, like certain like downloads or something, like you wanted to create an impact in your friend circle, who could mouth publicity to their circles as well. So with software, it's always been that you can achieve some growth, and people will really start to believe you and fund you. But it's not the case with hardware startups, because you really have to start a prototype, build it, iterate things, fine tune, and finally build a production version. And even in production version, you involve certain components, like you are aware of, like certain manufacturing challenges like casting and all, which requires huge amount of capital. So yeah, for hardware, it's always been a capital related stuff and a manufacturer related stuff. And for software, it's only, like, you would say that you getting if you find the right product and the right usage for a certain product, I mean, that is what you do before building a product. So then it's always an upstream for a software base. And the whole thing with startup, or the ecosystem that you're in, or the segment that you're in, is that you always have to keep innovating. Then the one or the other day you'll have to come up just to, I mean, like, just to strive in the market, until or unless you establish your name as a certain company or a manufacturer or any kind of stuff. So yeah, so these are the challenges. Obviously, I mean, external factors apart from these would be obviously accounts, handlings, and you have like finances. So these things are very normal. I mean that anyone has to do that.
So Harshad, thank you.
Yes.
So if there are no more questions, right? So we will meet after the lunch, exactly 45 minutes, right? So Harsha, okay, 45 minutes?
Yes, sure, sir.
So by 2:15 we will meet.
Definitely, sir.
So friend, join exactly at 2:15 through the same link, right? Thank you all. And a good presentation. It was a very good presentation. And hope that same thing will continue in the afternoon session, right?
Definitely, yeah.
Right. Thank you, Harsha.
Thank you.
So friends, meet you back at 2:15 exactly.
Harsha, thank you, Harsha. Anil Kumar, sir.
Harsha.
Topic.
Sir, just now Harsha on the left, sir.
Okay.
Okay. You could inform to the students regarding the same link or another link.
Sir, I'm not going to end this meeting, sir. It will be as usual, sir. They'll join the same meeting, sir.
Just inform to the students once again.
Okay, sir. No problem.
Right. So 2:15, okay, Anil? Right. So okay, Satvik, we'll meet again at 2:15.
Yes, sir.
Right. So thank you all.